Right, good afternoon, everybody. My name's Jason Fox. I'll be running the first part of this session. Let's talk about securing FIWARE architectures. The way that the session is going to run is that we're going to divide this into three stages. First bit, which is the one part which I'm going to take part in, we'll go through the principles of security components. These is because if you listened to me yesterday, I talked absolutely nothing about securing FIWARE whatsoever. Security is agnostic to the operation of context brokers. The thing is that obviously you do need to secure your system, and there are some industry standard mechanisms which can be used to secure HTTP REST services, such as current bindings for context brokers. And because obviously we're open source, we're open. We don't want to get vendor lock-in of any sort. We are open to multiple different security stacks. So what I will be going through is I will be picking one security stack. I'll be going through the KeyRock security stack and explaining how the various components work. Now, after going through the basics, then my colleague Stefan will be going through a different security stack, showing how to actually deploy the thing. And then finally, we'll move on to things like self-sovereign identity and your own creating your own credentials, and really advanced. So we're going very much from the basics through to the intermediate, through to the advanced. So you'll know where to look on the video if you want to review whatever level we're talking about. So let's just get the basic background understanding as to what is required for security components. Today, for the first hour, I'm just going to be defining terms, basically. I'll be defining what is identity management and what is the access control, which FIWARE components you could potentially use. There are a large number of security components which are within the FIWARE catalog. Obviously, they have slightly different use cases, or they fit together slightly differently. The ones which I'm going to show you are KeyRock, Wilma, and Auth0, which is one stack based around the KeyRock identity manager. There's another set from Telefonica which works around Keystone, and we also work very nicely with, say, Red Hat's Keycloak. This is not actually within the FIWARE catalog, but is we have a connector which works with, which is the FIWARE catalog. Anyway, in order to understand what these various components do, we need to define terms such as authentication, authorization, work out what the differences are, which level of control you will need, what you will need to be looking at. Now, the basis of a lot of these systems is OAuth 2. So again, industry standard for doing these checks. So we'll go through multiple flows which might be of use. A lot of this will very much depend on how your components within your microservices are communicating. Obviously, you don't need to have a user login if you're a machine. You need to go through a different throw. Now, there's a lot of three-letter acronyms, four-letter acronyms, and even five-letter acronyms which come up in security. So we will also explain the difference between a PEP and a PDP and a PAP and various other terms such as RBAC, PBAC, and XACML. Now, that's obviously an alphabet soup. The difference between the various things will become clearer as we go through the system. In all the cases with these three-letter, the third P is always point, and the first P is always policy. So it's only the middle letter we really need to worry about. So let's keep on moving swiftly on. If you look at the basic overview of the FIWARE catalog, you will see that there are on the right, and I've just put a selection of the security elements, are the crossing all three layers is the ability to handle authorization and access control. That's the section of coloured in red. There are obviously multiple components. All this is free open source software. One of the reasons why I get to use it, and there are obviously different connectors which could work according to your needs. But as I said, basically the principles are the same. Just a minute. Wait. Someone has decided to Skype me. Not now. I thought, yeah, I put that. Yeah, fine. Okay, I had put that on. They're fine. Right. Okay. So the reason why this is following all three layers is that you will want to protect all of your communications into your context broker, possibly even your communications into your, say, from your devices into your IoT layer, and then also moving on to the visualization tools or the processing as well. Everyone needs to be able to say, I am eligible for doing this, and therefore it is relevant to all three layers. So for the system, which I'm going to show off in a second, we're going to be dealing with KeyRock, Wilma, and AuthZForce. KeyRock is an identity manager. It explains who people are and what they are allowed to do. Wilma is a pet proxy, a policy enforcement point, which basically says either you're allowed in, permit, or deny, and let you in or deny. And AuthZForce is a policy decision point, which makes the decisions based on what information you've got. Now, the barriers between these three layers are a little bit blurred, because you could end up having a service which could offer more than one of these endpoints. KeyRock itself offers a limited PDP, as well as being an identity manager. It is possible, if you're looking at JWT tokens, that something like Wilma is able to make a decision based on on unencrypting the token, which again I can show an example of that as well. But classically, these are three different elements, which are three different microservices. The main features of KeyRock, these you might not need all of them, but it has, obviously the basic stuff is that you have users. But you can also have other actors in the system. So, for example, you would be able to classify an IoT device as potentially an actor within the system. You also can get various management tools, so that you can say, I want to change the permissions of all of these users. Or I want to delegate the information, because obviously you don't want to be stuck being the administrator of very large systems. You want to be able to say, okay, you can move people around. I will set up the permissions. You can decide who goes into which group. There are obviously support for multi-tenancy, different applications, different roles, and what have you, and also being able to do this using a GUI, which is the policy administration point, PAP. And as I mentioned, it does have a PDP of itself, although it is very limited, deliberately so. There's no point in trying to create a general bucket sort of security component. It just does that just to be helpful for simple simplistic scenarios. Now, JSON Web Tokens and permanent tokens. Permanent tokens is, and we will see an example of this, is basically a random string of letters and numbers which can be used to identify someone, whereas a JSON Web Token is an encrypted lump of JSON which has got some information about the user who has retrieved the system. KeyRock has recently been upgraded to be able to use MySQL 8. It is also compatible with MySQL 5.7, I think it is, and can also be set up to use Postgres SQL. It's a database. What would you expect? And you can also connect to external databases, or if necessary, you can go to somebody else's LDAP system, for example. Another thing which came up as one of the more unique features of Keyrock is that does support the European Identity (EIDAS) component. When you are looking for an identity manager, you should have a shopping list of saying, right, these are the things I need, these are the things I don't. Obviously, you need to say, okay, if it must do X, you can cut various components off your potential shopping list, and then you get your nice to haves. For example, there is also the security stack. We have a connector for international data spaces. Now, that is going to be specific or mainly used for connections from machines to other compatible machines. Not necessarily the most useful thing to do if you're trying to write a web service where you just need to log in and say who you are. Obviously, one scenario, pick the right tools for your scenario, but see what we've got. What the basic idea behind Keyrock is that it's got a database. It's got a database with these entities within it, and you define an application somehow. And I'll show the GUI and how to do things programmatically if necessary, which consists of a series of microservices, and users or other actors like the pet proxy or an IoT agent are allowed to be associated with that application. Within that application, you have the usual system of roles and permissions. Permissions, I'm allowed to do something, a role being a bucket of things you can do within that system. Obviously, this makes things a lot more flexible to just assign a user to a role rather than to have to go to every single individual permission they have. So it's a hierarchy. Now, it's possible, as I said, if you are a super user, to associate a user to an organization, and then organizations may also have roles. So you gain everything you've got personally plus everything you've got through the organization. This obviously makes administration simpler. You can delegate administration to certain users, saying for this particular organization you have the rights to add people, kick them out, or whatever, and then it's going to be a lot easier to get multiple people to set up your security system. The interface here uses both a GUI-based system, which is configurable. You can change the look and feel, or an API-based interaction. You can do stuff directly logging on, and you can go in and muck around with the system. Let's see some of this in action. That one there. Okay. I'm in the wrong place for that, so doing that one. Oops. What I'm doing at the moment is I'm going through the FIWARE tutorials. The majority of the security tutorials are currently under the V2 branch, and all I'm doing is I'm basically setting up a vanilla Keyrock. Whilst we're going to start, you will see here's the identity management. All I've got is a Keyrock. It is connecting to a database, and I have a few secrets. as you can see, I'm being very stupid here. I have hard coded in my administrator's username and password. This is very silly. You could, of course, add in more secrets into your data using various other components. So you'd never put this in properly. The other thing which you will notice, if you can see, it's very, very simple. I've just got the keyrock running. I'm not running HTTPS. I'm not doing anything secure. All my passwords are going to be going through in plain text. But this is just a demonstration to see what's going on. Let's bring up the security manager and let's bring up keyrock. It's taking some time to load up at the moment. Right, so I can, of course, oops, it's getting there. It's got there as well. I can log in as an admin. So admin 1234. Now that is obviously a very stupid password, but that is the default which I've been using. I can get into the API. I don't think I'll save that, and I've got nothing in there. I could just as easily log in using the API, as you'd expect. The way to get hold of a login token is through a post request, username and password, and we can send that through, and we can get from here. We would get a subject token. Who am I? And from that, I can actually get my user information. I've done this previously, just saying who. Depending on my access token, who I am. If I don't change my access token, it's going to say it's invalid. But if I place these in here, you can see I get some information about my user. I also would be in a position to create other users. So, for example, I want to create another user called admin2. I can do that as well. And you can see I'm abstracting out the database of which I've got the information about. If I now list my users, and each time I have to go in, I have to make sure that I have the rights to do so. Oops, that won't work. I can go in here and you can see I've now got my 2 users in here. Well, it's obviously a database. You can obviously do stuff with a database. You can update users. You can add in organizations and other people. So let's see that running with some data inside it instead. That should be sufficient. Right. Need to kill. Oh, just a minute. This is stop. Start again. Still running there. Just with Docker Network PS. Oh, just a minute. Wait a second. I need to kill the previous system. It's not killed it. That's why. My bad. That's better. Oh, it still needs to be work group. Yes. I've finally got rid of the other one. Start up again. Right, so this time I'm going to start up the same thing with some users in the system, so you can have a quick look at the GUI. What I also have is localhost 3000. Once it's like I have a little mechanism to log in to the system in various different ways. So I have to be quite careful here because I have long-term tokens to make things simpler. So if I just go to KeyRock again, it should go with the front end again. It takes a little bit of time to work out what the CSS and look and feel is. It's just a one-off startup, which takes a little bit of time whilst you look at a blank screen. There we go. So this time I'm going to log in as Alice the admin. And you can see I've now got some applications in here, and the application itself has got some credentials. This is very useful because it is required for when you are trying to make various OAuth connections. You can see I'm able to retrieve either JSON Web Tokens or permanent web tokens. And in this particular case, I've got a JWT secret, which I can use to decrypt my JWT should I request one. I also have got a pet proxy set up for this one. So this is another component, another microservice which is able to access the system and able to connect. And I believe I've even got an IoT sensor set up. So you can see I've set up multiple components. What's more, if you look at my users, I've got multiple users in my system, and some of these users I've placed into a group. So Alice is in the management group, as is Bob and a couple of other managers, and they are authorized to use this. It shouldn't be difficult to work out that this is a backing database. Now, I need to be quite careful here. This might or might not work. I need to log out, sign out. Right, okay, so I hope that will work. Once again, I can log in as Alice, and you can see I've got information here. It's saying here that I'm using what KeyRock calls basic level authorization. It means I'm using the PDP directly, which is connected to KeyRock. If you look into KeyRock, I forgot to do that. One tab. I need to log in again, sorry. If I go into, say, I think it's the more, is it Alice? No, that's management group. And manage or edit is edit. No, that's editing the group. Homes. Sorry. Oh, no, applications. Get the right. Applications. Fireware tutorial has got application. I have various roles, such as security team, and security team can do various things like ring a bell or unlock the data. Now, if I look inside here, you can see I've got things like an HTTP request. I can do a post action on bell. You can do this using regex. You can do this down to an attribute level should you wish to do so. Obviously, how you do this will depend on which IDM you're currently using. Now, so I know, yeah. So there are multiple ways you can log on using so-called OAuth 2. The basic idea here is that you need to you can log in as a user, obviously. So you pass in your username and password, and you can come back out. But more interestingly, is that you can ask the IDM, do you vouch for this user? So in other words, what you do is you attempt to log in to a system. It says, would you like to log in using KeyRock? And KeyRock will say, when you log into KeyRock, it will say, do you know this guy? It will then return an access token if you're successful. And the access token can then be used to confirm who the user of the trusted source is. It's 2 steps rather than 1. So in order to show you that, I am logged out, hopefully. I can log in as Bob the manager using an authorization code. And it tells me, as you can see, it's gone from my original code, software, my original application, to a key for KeyRock. So I'll log in as Bob the manager. And he's asking me, will you allow FIWARE tutorial to gain some information about you, and it's saying I want to be able to pass on my username and various other bits of information. I could deny and be thrown out again. If I authorize, it then goes back into the system. I'm no longer access denied, but I've now got an access token, which I can then use to log into the system. Now, Bob, the manager, I believe, can access the store. Any logged in user can do this. So it's let me into my store. I can do things like buying beers. You can see the number going down, but I believe that they can also ring the bell. So if I go over to the device monitor, I can then ring that bell. And as you can hear, the bell goes off. It doesn't give me an access denied. Now that is because Bob is within the group of who have this ability to do that post on that post action on that ring of the bell. And of course, it's not that this application understands this. It's being passed for adjudication by the PDP. In this case, the Keyrock is taking the role of the PDP as well to say, is this access allowed or denied? Looking at it in more detail, if I try and access, we can see I'm trying to access a resource, and because the auth token has not got a valid value in it at the moment, it would not let me in. And of course, if I again, I'll go in as Alice uses the password grant with the other grants. I can put in all cases, I'm grabbing an access token. The access token, if I put this in here, it will now give me data. It's giving me the data in the form of that's Jason, form of various different stores. So you can see I can protect my pet proxy. I can protect my system by adding in this pet proxy. What is the pet proxy actually doing? I think I've got the code running here. This is running at full debug. You can see it when it starts up. First thing it does is it checks has it. I'll stop following. It's going to make life easier. It loads up various components. Needs to know who its IDM is, and it can connect to the IDM, and then it is being used for authentication. This is again the simple "Who am I?" If I am someone, then I'm basically allowed in. I've got the simple rights to do so. If I'm authenticating a user, I pass that token, and as you can see, that's the one I did here. Here I go. So if I tried it without anything, it would return an error message as invalid token. However, if I put a proper token path, it's permitted and it will return. When it's doing the public path, it's because it's that's looking at the heartbeat of the system. As I said, there are multiple OAuth 2 grants which are available here. The first one with just username and password, we all know what that is. The second one I showed you there was an authorization code grant where you go off, am I allowed to put the information in? Can it come back? There are a few other grants. You're able to use things like saying, I'm a mobile phone. You need to have an implicit grant, so it's simplified the system. Whereas it is also possible to do things like obviously get a refresh of your token. If I go back to Keyrock again, can I? No, I won't go to Keyrock. I'll go here. Yeah. If I go back here, you can see when I logged in. I'll just log in again. I've got an access token, but I've also got a refresh token. Now, obviously, my access token is only going to allow me to log in for a short period of time. Obviously, that's going to be configurable, but I can also use a refresh token to say, I've run out of time, give me a new one, or I'm running out, I'm low on time, so I can get a new one. It's as you would expect. I think I've got the refresh token somewhere. There won't be in PEP. It'll be the identity management, I think. Yeah, I can put the refresh token in here to get a new token back out. So if I grab this one, I think I can put the token in here. It says, okay, I was invalid because of my invalid token. I don't know why I'm invalid that. Let's have a look at the way that particular API endpoint works. But I can actually get a new token. Should I get the URL correct? For whatever reason, I've got the wrong one there. Okay, so let's move on. Where are we? The pet proxy itself, as I said, is effectively a gatekeeper. The pet proxy has just got one job to do. It retrieves the incoming request, forwards it to someone else to work out what we should do with it, and then either lets you through or sends a deny message. It is possible to set this up and connect with multiple different systems. You can connect it through things like API Umbrella or Kong if necessary, and it can also support web tokens. Now, I'll have a quick example here, which is relevant for iShare project. I've got the wrong project. Project open recent workspaces. That's it. So if I go in here, this is an example of a JWT token I've got on the screen at the moment. Right. So if you look at the iShare stuff, it is possible to right. It is possible to have a token which is a JWT token, an encryption of a certain amount of information. In this case, I'm having an encryption of my application. You can see the application was in Keyrock, and I've got a certain amount of policies saying I can do this with this FIWARE endpoint. I can do this with that FIWARE endpoint. So in this case, I can get hold of a soil sensor, and I'm able to update the temperature and things like that. Now, it is possible if I scroll down, so if I make a request, it will then read through that information and make a decision point, because a JWT looks like this, and you could actually decrypt the JWT on a website if you know the magic number. You remember when I went into the Keyrock GUI, you could see that I had a magic key there, which was saying this is what I was putting into the system. I can then see whether this is relevant or not. I could also set the pet proxy here is flexible in that it can work with multiple different systems. And indeed, if you have more complex needs, you may need to push the policy decision point over to another system. CForce is an example of a PDP. It uses something called XACML, which is a XML-based version of setting up those rules, permit and deny, which means that you can make decisions and change the basis of those decisions by updating the PDP server. Obviously, XACML is an OASIS standard. It's one of the mechanisms you can use for making these decisions. There are others, of course, and it is extensible as necessary. what would happen with Auth-CForce is that you'd need to have multiple elements into the system. Now, in this case, I'm the stock management front end. I want to access, I'm a user, I've got a token or what have you. I go to Wilma. Wilma then, the pet proxy, needs to get hold of the user from Keyrock, and then it needs to pass or delegate the decision making over to Auth-CForce. Again, both Wilma and Auth-CForce may need to connect to Keyrock before they go to the context broker. They can be XHTML rules can be very verbose, but they can be very fine grained. Here is an example of a very simple rule set. This is the equivalent of that post ring the bell, which we did for the Bob the manager. And you can see here that the bits in white are the bits of information you actually need. So for people who are in the role of a security role, like Bob, they are able to do the action of post on the resource called bell stroke ring. Okay, description is and the overall effect is permit. You can actually make these rules more complex. So you could have a rule of a manager is able to delete anyone who is one of his subordinates. The problem, or you could have, I can ring the bell only after 6 o'clock in the evening. And the problem being, of course, that this is just a decision maker. So if you are unable to supply the relevant information for the request, the default is going to be deny. So if I don't supply the fact that or that here are Bob's subordinates, then if I make the request without that information, then it's going to say deny. If I need to pass in to the system the additional parts of the policy. Obviously, things like time can be based on the timing on the server, so you've got no problem there. I've already shown you the basic OAuth 2 flow, which, as I said, you get the access token to get the user request. But within the overall structure, there is potentially a need to place a PEP between services. If you are dealing with the marketplace components, it's not sufficient to just be able to log into the system. The marketplace itself needs to check, do I get hold of the resource or not? Do I need to pay for the resource or not? As I mentioned, there are 3 levels of identity management supported within this system. The first one is authentication. Authentication is really simple. If I exist, I have the right to do stuff. Now, obviously, you need to check that I am a user. Within my little tutorial system, I had some various nefarious users who had accounts, which would mean that they would pass the authentication test. Yes, they are a valid person. If you're doing something like that, then obviously you need to have appropriate logging in place to work out that this user did that. It's more likely that you'd use authentication where I am in control of my username, password. I'm in control of what I personally can do. So if I go into GitHub and I want to do stuff, it's going to be me logging in on my account. That's sufficient to let me do everything for me without necessarily going for higher levels of rules. And you can see all that this is basically a connection between your service. Go off and get who am I, and check that the token exists. The level 2 is moving on to saying not only have I got a user, but do I have various rights? And again, this is relatively simple. In this case, the first case, I would use Keyrock is my PDP, which says it gives you the rights. If I want to get more complex, this is when we get into your XACML rules. This is where we need to get into the ability to do advanced authorization. What else can you do? Well, it depends on your IDM. I mean, I've just shown you Keyrock. As I said, other ones are able to do other things here. But one of the things which Keyrock is able to do is this JWT token. And you can see the effect is that there is a horrible string which you've got no idea what the data is in. But when you decode it, you're able to retrieve proper information out of the system. So your PDP, wherever it is, would be able to work out, yes, this demo user is in this role and it has got sufficient rights to do other things. There are other parts which are available within Keyrock. As I said, it is possible to use national identities. So I could log in and claim to be me. I could put my the details from my identity card into a system, and it would recognize who I am. And now, of course, if I'm a German citizen living in Spain, I wouldn't want to. I would log into the Spanish system, and it would forward me to the German system to work out, yes, I'm actually German, and you can give me the rights to do this as well. There is also various other elements which are may or may not be relevant to your use case, but I'm saying it's integrated into this system using access policy. The important point here is the final bullet on this slide, which is saying it's transparent for users. If you're looking at using iShare, you'll find that EIDAS, I believe, is one of the notifiers you can use for your user. This is showing how the flow works. The difference is, as you can see, by this point, what we've got with Keyrock is that it is now flowing into another third-party system. It would work equally well with with an LDAP to go off to, in this case, an EIDAS node, or even possibly multiple EIDAS nodes to get hold of the information. There is a limited amount of possibility for doing data usage control through this system. I won't go into detail, but you should probably be aware of it. And that, in summary, is the basic introduction to identity management, so that you can understand the complex stuff which Stefan and Jesus will be dealing with. So identity management deals with usernames and passwords. Access control is the bit which says, who are you, or is Jason allowed to do this to that? Obviously, the authorization itself could be roles-based or policy-based, or indeed you could be looking directly down at the attributes. The various PEP, PDP, and PAP, and indeed there's PIP as well, can be, these are standard OAuth 2 terms. There are multiple components. You're not forced to use a specific security stack, but we have multiple security stacks which work perfectly well with FIWARE. We have multiple security stacks such as Keyrock, Wilma, or CFORS, which not only work with FIWARE but are also happy to be associated with this in the FIWARE catalog. Which means they follow various rules according to our releases and what have you. I would say you need to make your choice based on what your use case is. There is obviously more information which is available on GitHub. The main place to start looking is the FIWARE catalog itself. So I won't keep you too long on this particular session because this is quite basic. But I would now be able to take any questions, or I can pass on to Stefan and you can learn something more difficult. So if I stop sharing at that point, can we pass over to Stefan? Or there are some questions in the chat. Just a thank you. No, thank you for attending. We want the PEP proxy to verify that a JWT is signed by a particular key and it sends certain claims. Can this be done with Wilma? As far as I remember, when you configure Wilma to do this, you would, in its configuration, you would put the key would actually be placed in the configuration. So you would be able to work out that it's signed by a particular key. You would then be able to decrypt the JWT within the iShare compatible endpoint. It is possible to do this, prove the claims. Now, Wilma is a very, very simple PEP. So if it doesn't do what you want it to do, it would be quite easy to extend it and add in the system as necessary. That's what I've done when I've needed to do something more complex. So let's say you want to use auth-zforce and you need to pass in, I don't know, a user's email address as one of the elements for the claim. I would take the original source code and modify it as necessary. Will I share the slides of today's session? Most certainly, yes. All of the information we are dealing with today is going to be published. If for whatever reason I fail to send it to you, then you can just ping me on LinkedIn and say "oi," and I'll do it again later. The slide deck I just showed you, the basic stuff. I've already published this slide deck before, but I can publish it again. What components should we use for the experiments? That is a very tricky question. It should be the case that with each FIWARE release, the stack of components, so say the keyrock stack, keyrock, Wilma, or auth-zforce, should be updated to work with itself together. So my general rule would be go for latest or latest released version. So whatever was with the FIWARE 8.3 overall release. Of course, if you are using components which are outside of the FIWARE catalog, then it's a matter of finding something which is compatible. Once Stefan starts talking about Kong, for example, he'll be able to say what base version of Kong you'll need to use and which parts of the plugin we've got would be usable. Obviously, the difference between stuff inside the FIWARE catalog and outside the FIWARE catalog is that we don't have an agreement for the release schedule of, say, for example, Kong. It works, but it's not something we have a release schedule with. The video recording of the system is video recording the system is going to be published. And yes, my Skype went off even though I'd actually set it to do not disturb. So blame Skype for me phoning home at that time, Nikos. Okay, right. If Stefan's ready, you can take the reins.
Okay, then I will take over. Let me check if I can share my screen. That is probably now my screen. I would start with one addition to Jason's answer to the versions. Besides, I would fully agree to always use the latest released version, especially in the context of the IFOR-Trust experiments. We also have the IFOR-Trust tutorials on the GitHub organization for IFOR-Trust, and there are reference examples, I would say, of installations with where you can take a look which versions we currently recommend to be used in the experiment. This will be updated over the course of the experiments, obviously, because the components will evolve still evolve through the time. But you can be, let's say we make sure that the components that we reference there work together in the versions that we show in the tutorials. Okay, now to my part. Yeah, I wouldn't say it's more complicated than what Jason said, because he already laid the foundation with all the theory behind it. My part will be more practical, so it's about how to actually secure the FIWARE system in a production environment and using various components for that. For example, Kong, Keyrock, Keycloak, or IFOTrust. Yeah, as you probably have seen in Jason's presentations, it's mostly about that we have different options to do this. So I have a lot of components mentioned here, and now I will start with how we use them. Okay, first I would start just to basically talk about the role of an API gateway in a FIWARE platform. As you already know, in a FIWARE platform, the context broker is basically the central component. And context broker usually gets contacted by various actors and with different requirements for each actor. It can get contacts from different external actors like human beings, like some external services or IoT devices. It can be contacted from internal actors like a service that adds some value to the system. Basically, most of the time the service that you will basically develop on top of the context broker, or of an IoT agent that is directly connected to the devices, basically keeping them away from the context broker. All of those actors also will have different load behaviors. So an external service will contact most probably not as often as a huge number of IoT devices. And a user also usually behaves different than the automated contact that you get from a service or from IoT devices. And as Jason also explained, the broker itself currently doesn't have any self-defense mechanism, how I would call it. So the context broker itself doesn't enforce any authorization, authentication. It also doesn't have any mechanisms to protect itself from a lot of load. Yeah, this diagram looks a little, let's say, abstract. So put this into a real world example. The value adding service, for example, could be an application which shows you parking lots in a smart city context. So our user accesses this parking lots application, which gets its data from the context broker. We have an external service that writes weather data to the context broker to further enrich our smart city platform. And we also have smart lamps that have that act as the IoT devices that read and write their status through the IoT agent to the context broker, so that we can also use this information, for example, to make decisions in regards to our smart city. Okay, but now we also have to somehow secure this system. What do we need for securing the system? Yeah, we need to apply access control. Jason already explained what PEP and PDP means. So we need the API gateway, in our case, to act as a PEP proxy, and in some cases also already as the policy decision point. PEP means that we need the API gateway to basically enforce the decisions that it got from external components that will act as the policy decision point. For example, Keyrock, Keycloak, or some IFOTrust components. This allows the API gateway to allow control on who can access what. For securing the system, we also have additional requirements, usually like rate limiting. So we don't want that, let's say, a misconfigured IoT device brings down our whole platform, because all of a sudden it doesn't update its status every 5 minutes, but instead every 5 milliseconds. We want some usage control usually. So that we can check who does access what and how often does it do it. Do they do it? And we also want to have some monitoring to know what's happening in the system. So do we get an unusual number of unauthorized requests? Do we get an unusual number of requests that are forbidden or only failing requests? That's something that we need to know about our system when we secure it, so that we can act properly on it. With an API gateway as the central entry point, we can provide those capabilities. Okay, so how will this architecture then look like with an API gateway? I now did put in some logos, which will mostly be in the context of the architecture that we describe here, and that you can also find in the tutorials for IFA-Trust. We still have the Origin Context Broker in this case as our central component that basically holds all the data and serves the additional services. Our normal, let's say, human user connects to the system through not through KeyRock but also through Kong. But our human user is registered in our identity management system. In this case, we use KeyRock. KeyRock is an IDM from the FIWARE catalog that Jason already explained. So our user can get an access token from KeyRock and then connect through Kong with this access token to the value-adding service, in this case, for example, the parking lot application. Kong, as our API gateway, then will validate the token and forward the token and the information about the request to KeyRock so that it can decide about the actual request. Inform Kong about this decision so that we then can either deny or allow the request and forward it to the service or deny it. Another use case is for the IoT devices. In this example, they will handle the authentication part with the IoT agent itself. An example could be that they use some certificate-based authentication mechanism. So the IoT agent already ensures that the device is actually the device that it's supposed to be. But we will use Kong then to enforce rate limiting, which means for every device, only a certain amount of requests is allowed per second or per minute, depending on the configuration. And only that amount is forwarded to the context broker so that we save the context broker from basically getting overloaded by, for example, misconfigured IoT devices. Then we have our third actor, which is the external service, in this case, a weather service, which can be, for example, registered as a participant in an IFA-Trust, in the IFA-Trust framework. So the external service will then contact the API gateway with a token that it got according to the IFA-Trust documentation. So it will be a JWT of a specific format, signed with a certificate from iShare. And Kong then can do the policy enforcement based on the policy decision, policy enforcement based on the token. It will, in this case, take the token and first validate with the iShare satellite, which is acting as a trust anchor here, that the external service actually is a trusted participant, so that we can trust the external service. After it's verified that the external service is a trusted participant, it will then go to the iShare authorization registry, which is providing us the policies in the, let's say, in the wording of Jason's descriptions. This would be the policy administration point. So that Kong then can get the policy and validate the request in regards to this policy. So is this external service allowed to do what it wants with my context broker? And again, Kong will then either allow or deny the request. Beside those mostly authorization focused tasks, we also have the monitoring part that we can apply with our API gateway to basically all of the requests. And we're using standard tools to then to store the monitoring and make it visible. In this case, we use Prometheus to get the monitoring data from Kong and make it visible within Grafana. So now I probably have to explain why we did choose to use Kong in our FIWARE system, because obviously it's not part of the FIWARE catalog, but it's a very proper solution to have an API gateway for our needs. Kong is currently one of the most popular and also most adopted solutions in the market. There are other API gateways, but yeah, they are, Kong is just one of them that are really frequently used, that has a lot of documentation out there and is quite used by different companies. Kong itself has an open source version and also an enterprise version available. The open source version is maintained by a huge and very active community, so that it's ensured that it receives regular updates, that we have, as mentioned, a lot of documentation about it, that it continues to get new features. And mostly that we as FIWARE don't have to do this ourselves, so we don't have to maintain a full API gateway, but rather can use an existing open source solution. Kong also provides us production-ready deployment tools, so there is a huge number of options to deploy Kong basically in any environment. One very important point for us was that Kong has very flexible plugin support. So we can provide the FIWARE-specific functionality as a plugin into Kong instead of directly manipulating the code. The plugin framework supports various languages, most notably Lua, Go, and Python. And there is also Kong Hub, which provides already existing plugins for our additional requirements, for example, a rate limiting plugin and a usage monitoring plugin. Now, Kong Hub looks like this. There are quite a huge number of plugins for various functionalities. You can see here there's authentication, security, traffic control, serverless, analytics, monitoring, and so on. And there usually are 3 levels of plugins. There are the free plugins, that is what we mostly use. And then there are also some more advanced plugins like the Kong JWT signer, which is available in the enterprise or in the plus version of Kong, or even some that are only in the enterprise version. For our needs, they are currently not needed, but it's nice to at least have the option to extend the system even with enterprise functionalities. Okay, now more on how to run Kong itself. There are, as I mentioned, a lot of different solutions available on how to run. There is the documentation on install and run. I can show you. It basically presents all the options that you have, how you can install it playing from the packages, how you can run it on different Kubernetes installations, how you can run it with different options in Docker, and even how you can run it on your Mac OS if you really want. But in general, it should be it should have a proper documentation on every, let's say, sane version of running an API gateway that you will need for your production environment. Yeah, that's another nice thing on having an already existing API gateway here. We don't have to write all this information ourselves, and we don't have to keep it updated because we will mostly have 1 or 2 environments running. So we cannot basically provide the support for every exotic environment, but the community behind Kong can. So we can basically make use of it. We ourselves run Kong with a Helm chart on top of OpenShift. You can see the Kong that we have running here in our GitHub repository. So all our configuration is publicly available here. Yeah, some details about this demo environment. As I mentioned, we use the official Kong Helm chart to install it into our environment. We did extend it with support for OpenShift roots, which is more or less a detail to make it more compatible with OpenShift. In a normal Kubernetes environment, you will use the Ingress object most probably, but that doesn't really change the functionality. We use a pre-built image from FIWARE of Kong that already includes the plugins that we built. That's the recommended way to provide plugins to Kong. So there is a base image for Kong that you enrich with the plugins and then provide it. So we have this image available on Quay.io, and our plugins are again available on GitHub. For our Kong, we use the declarative configuration method. So you can configure Kong basically through 3 methods, either declarative with a config file, via the API, or even via a UI that makes use of the API. For API gateways, I usually prefer the declarative method because then you can apply all the, let's say, processes to ensure the functionality and the access control on how to set up the APIs. You can, for example, put it through a pull request process so that you can have basically the security that nobody accidentally breaks access to your APIs. But there are other options available. And we apply all our deployments via GitOps, which is why we can provide them also publicly on GitHub. Now, how do we configure Kong to act as a PEP proxy in our systems? That's where the plugins come into play. So we as FIWARE, we did build basically 2 different plugins, but they support different run modes that allow us to use Kong as a PEP. There is the NGSI iShare Policies plugin. I can go to it. It's available on the FIWARE GitHub repository, and it's a relatively small Lua plugin, which handles basically the whole iShare flow to do the authorization. So the plugin receives the iShare token, then it will take care about connecting to the iShare satellite as a trust anchor to verify the participant, and then also retrieve the policies and make the decision itself. So the NGSI iShare Policies plugin, therefore, is not only a PEP plugin, but it is also a PDP plugin, because it will enforce the policies, but it will also do the policy decision itself. It will only use the iShare authorization registry to retrieve the policies. The other plugin is called the PEP plugin, the FIWARE PEP plugin, which currently supports 3 different modes of PDP. It can use KeyRock as a PDP, it can use Keycloak as a PDP, and it can use a more or less generic authorization endpoint to apply to connect to basically other PDPs that will comply with this API. In case of the PEP plugin, Kong will simply forward the request to the PDP with some the token together with some request information, and then takes whatever decision it gets as a result from the PDP. So if KeyRock tells Kong to deny the request, Kong will deny the request and do not anything else. If KeyRock allows the request, it will simply forward the request to its original target. With KeyRock as PDP, we can do the role-based decision making that Jason described in his presentation, and I will show more examples in the next slides. We can use Keycloak as PDP, as I mentioned, where we delegate the decision to Keycloak's authorization endpoint. This is more or less very similar to KeyRock, so you can also define the roles there, and you can build permissions or even policies in Keycloak that are then used to make the decision on the request. And as mentioned, we have this external auth functionality, which is also acting very similar to Keycloak and KeyRock, but can be used to connect to, let's say, more specific external authorization endpoints like our DSBA PDP, which is a policy decision point that should make decisions that are compatible to the current Data Space Business Alliance workflows that are currently in, let's say, in definition phase. For example, to support the usage of verifiable credentials for authorization. That's something that Jesus will talk more in detail in his part. Okay, so now how to configure such a plugin in Kong. I will start with basically a general plugin configuration. Most of the code that you see here is applying directly to the Kong Helm chart, but exactly the same mechanism can be used, for example, to run it with Docker, or very similar if you run it, if you directly install it to some VM. So basically, Helm will translate this part into environment variables. If you use those environment variables in a Docker container, you will get the same results. To enable a plugin in Kong, we basically have to tell Kong to use them. In this example, we will use the bundled plugins. The bundled plugins are all the freely available plugins from Kong Hub. They are already built into or packaged into the Kong base image. We tell to use the PEP plugin, and we also want to use the NGSI iShare policies plugin. Then we see the difference between PEP plugin, which is written in Go, and the NGSI iShare plugin, which is written in Lua. The Lua plugins only need to be mentioned here, and then they are automatically loaded. For the Go plugins, we also have to define the plugin server and a start and query command for the plugin itself. This will always look the same because the base functionality for this is provided by the plugin framework. But it needs to be configured, else the plugin won't start. And we also tell Kong to don't use a database for the configuration, but instead use a config map, which in the end is the declarative configuration. Okay, so now let's start with some more specific plugin configurations. So if we want to use with the general plugin configuration, if you want to configure a certain plugin, we have to define a service first. So we instruct Kong on which request it should intercept and to what endpoint it should forward the service the requests. We will have a service here which we call Orient keyrock, basically for making it better visible, better finding it. Then we tell the service that it should secure the host FIWARE Orient LD. FIWARE Orient LD in this case is an internal name in our Kubernetes cluster, which makes our Orient instance available there. We tell it should forward to port 1026, which is the port Orient is commonly running at, and that it should use the protocol HTTP to forward the data to Orient, because we do the SSL termination already before the API gateway. Then we define which routes the service should serve. So we have the Orient keyrock route that is available under the path /keyrock. If you configure it that way, in the end, it will receive all requests that go to the Kong host. In our case, kong.fiware.dev/keyrock, and everything that comes through this endpoint will be forwarded to this service, and all plugins will be applied to it. We configure it to strip the path, which means that before Kong forwards the request to Orient, it will remove the /keyrock because Orient itself won't be able to do anything with the /keyrock. So that's quite important here. And we also, and then we can configure the plugins that we directly that we will apply to this route. In this example, it will be the PEP plugin, and then we will have the plugin specific configuration below this. Okay, now to a more specific example, and also the, let's say, live demo part. I did configure our keyrock to our Kong to use keyrock as a PDP. As mentioned, we configured to a secure Orient available on the port 1026 with the protocol HTTP, and we intercept everything that goes through /keyrock. If that's done, we have to configure the PEP plugin. That's the Go plugin that I presented before. That it should use the authorization endpoint type keyrock, which tells the plugin that it should use keyrock for PDP. Then we have to tell where the keyrock is available. I have one deployed under keyrock FIWARE.dev. And we say that it should use /user as the authorization endpoint. This is basically a definition by the keyrock API. And we also tell which app ID it should use in keyrock. So in keyrock, every role basically belongs to an app. And if we want to use the keyrock for authorization, we have to configure the correct app ID here. And then we also apply one of the standard plugins to this request, which is the request transformer, which instructs Kong to remove the authorization header from the request before forwarding it to Orient, because especially in the case of Orient doesn't like any header that it doesn't expect. So it would fail if we also forward this header to Orient. Now let's go to the live demo part. First, I have my keyrock here. That's the one at keyrock.FIWARE.dev. And I already configured a test application, which is here. It's called test app. It does not a lot, but it's basically the ID, the ID that I already configured inside our Kong. For the test app, we have basically two users. One is test and one is the admin user. And we have for our application also some roles configured. I have to go. I logged incorrectly. Sorry. So we have our user here in this application. What's going on here? There's my application. That's not how it should be. Okay, I have to check why the front end doesn't work as it should be. So you have more or less to trust me now. I pre-configured those two users to be one being the admin that is allowed basically to request everything on Orion, and the test user is only allowed to request the NGSI endpoint. So first I can show you that we can make now a request to our Kong at the path keyrock, and we try to access an endpoint on Orion. I did not put any authorization here, so we will probably not allowed to do this. And as you can see, the request is forbidden by the authorization service of keyrock. When we now get a token from keyrock at the keyrock.FIWARE.dev, and basically the same manner that Jason described in his presentation, I will now use this user test.FIWARE.org with its password and get a token from there. And then I can try the exact same request again. So we go to keyrock, NGSILD, and request for a test entity. We have to use this token as a bureau token. And then we are basically allowed by Kong to retrieve this data. What happens here is Kong will get the request at keyrock at this path. Then the PEP plugin will be applied, which will take the bureau token, the path and the body, and also the HTTP action, and forward this information to the keyrock API. Keyrock will check the roles that are connected to the token, check the permission, and send us back either a permit or a deny for the request. If we now use the same token to request a path that is not NGSILD, but rather the version path, we will see that this is still denied. So you can do quite a fine-grained request, let's say fine-grained configuration of the permissions that should be applied to your requests, and let them enforce by Kong. So the next example is for I4Trust. So I mean, we're in the I4Trust training camp, so this is probably very, very interesting for most of you. The first part basically is again the same. We configure to secure Orion, and we now offer a path called I4Trust. We configure a different plugin here. So the plugin that we will use is the NGSI iShare policies plugin, and this is the plugin that should be enforced on this path. We have to configure where the access token comes in on this request. It's authorization. Then we have to configure some very iShare specific things. So we have to tell Kong where the authorization registry is located. We're using the iShare test instance here. I will not go into the real details of iShare now and the I4Trust framework itself, because we will have a couple of sessions in the next days, as far as I know. So the authorization registry basically holds the policies and defines what permissions in the end, which user or which organization gets Yeah. And then we have the satellite configured as a trust anchor. So the iShare satellite provides us with the information on which participants we should trust at, or we can trust at. We also, again, use the central iShare satellite instance here. Yeah. And then there's also the configuration of the identifier of Kong. So in the context of IFRTrust, you have different, you can act as different roles. And if we provide data, we're a data provider. And we also have to be a trusted participant. If we're not a trusted participant, the authorization registry and the satellite will not answer us. So we need an identifier, and we need our private key and our certificate chain so that we can sign our own tokens and make requests to both of those entities so that we can use their information for our policy enforcement. Now let me show you how the requests will look in this case. Let's first again do an unauthorized request. So the request itself looks basically the same, only that it's now on the path IFRTrust. And we will get an unauthorized. The message looks different here because the plugin has a different response format, basically. But yeah, the nice thing is that we now see that we end up in another plugin. For IFRTrust, we first have to generate our own token. We will request as the participant Happy Pets, which is basically an entity out of our reference examples. And our Kong will act as the data provider with the identity packet delivery. So I have a small tool running which will generate me a conformant token for Happy Pets with the audience packet delivery. So we now get an iShare compliant JWT token. I can give you a short look on what's actually in this token, and then we have to get a new one because iShare tokens always only are valid for 30 seconds. So our token has first the full certificate chain in its header. This is basically the client certificate. This is the intermediate, and we have the root certificate as the last one in our header. Kong then first does validate the CA. So the root certificate is the thing that is provided by the iShare trusted list, and we should only trust such tokens in case that the trusted list tells us to do so. So this certificate needs to be registered in the trusted list of our iShare satellite, else we should reject the token. And then the token itself has some very basic information. So we have the audience packet delivery, and we have the issuer Happy Pets. And we also have the subject Happy Pets in this case because we're requesting for ourselves. And then there is the experiency and the issuance date. So basically very standard information about the JWT token. This token, with this token now we can go to the IAM system of our participant and exchange it for an actual token that we can use for connecting our iShare our Kong. So I generate a new token because 30 seconds are probably over already. I'll take the token. And then I get an IFRTrust token. We use KeyRock here as the system again. We call KeyRock. So I did something. I probably didn't copy everything. Oh, I have copied it to the wrong position. No. Okay, I did probably miss something when copying. So we go to KeyRock and basically exchange our token to an iShare token in regards to our participant. We can take a look at this access token also. We have a little more time because they can now be valid for a longer time. But the token itself looks pretty much the same. That's also, this time it's issued by packet delivery. So from the key rock that we are, and it's for your subject happy paths, which is basically we as the requester. And the audience is again packet delivery, because I now can use it to go through Kong, through the data, to the context broker secured by our by packet delivery. Now let's take the token and make a request. Basically the same request that we did before with this, and we get back the decision. You have seen that this took longer than the first request that we only had with KeyRock as a PDP. I did not enable any caching currently in this in Kong, basically for our presentation, because I don't I wanted it to show fully. And the first request then takes quite some substantial time. In this case, 1.5 seconds basically, because Kong in the backend then has to retrieve the policies from the AR, which is a request through HTTP. It has to request the trusted list from the satellite, and then it has to go through all the checks. So the initial request will be relatively slow, but parts of it, for example, the trusted list, can be cached, so the next request will be much faster. I did ask now for an entity of type delivery order, which is the one which I created a policy for, so that it's allowed to be retrieved. We can use the same token to request an entity of type non-test entity, which obviously is not an entity of type delivery order, and use the same token. And now we get the answer that there is no such policy in our authorization registry, which means we are not allowed to access it. We get the 401. And now we have to take care that somebody gives us the permission if we really want to access it. So now we have the hypertrust. Okay. We also have the option to use Keycloak as PDP. We have the basically same boring start of the configuration. We have again our host Orion, and now we make it available under the path Keycloak. The pet plugin configuration looks very similar to KeyRock, only that we now tell it to use the endpoint type Keycloak, and that we give it the authorization endpoint address FIWARE minus Keycloak. This endpoint address is an internal address. So for KeyRock, we use the external one, and now we use the internal one. This is basically only to show that both is possible. It depends a lot on the environment. If you can use the internal, or if you always should go through the external addresses, that depends very much on the use case. For the Keycloak plugin, we have to tell which realm to use. This is basically a Keycloak specific thing, similar to how we use the app ID in KeyRock. We also have to provide the client ID and client secret, so that Keycloak can check the permissions basically in the right context. So a permission in the role in Keycloak also is only relevant in a certain context, and we basically tell the PEP plugin which context it should use. I will not go into the details of the Keycloak configuration. You can find an example of our realm configuration, which includes the users, clients, and roles that we use here under this link in our GitHub repository. And I will now go back to the example. So I configured 2 users on Keycloak. One gets a token with the role consumer. We have the client secret and the client ID here, and username and password to get a token. Now we get back a JWT token, which we can now see has the role consumer in it. You can find here. So it has, in the context of the client Orion PEP, the role consumer. And if we use this token now, it's a little longer valid, so we don't have so much to Yeah, so don't have to be so fast. And now we get back the delivery order. Basically the same as we had for IFOTrust or for KeyRock, only with a different token type. If we get a token for another user that doesn't have the role consumer, so we have the username here again and the password, we get our access token. We can again check the token. And we now see there is no such role. It has only the standard roles that basically every user has, but no rule or in PEP consumer. If we use this token, we now get a request is forbidden by the authorization service Keycloak. Very much the same as we have seen for KeyRock or for IFOTrust when we did unauthorized requests. Okay, that's the example for KeyCloak. Now the next one would be the example in terms of rate limiting. As I mentioned, it's not only about authorization when you secure your system, it's also, for example, preventing it from getting overloading. So we can use the already existing rate limiting plugin. We again configured the same host and routes, and I configured a specific route for this, but only for the sake of demonstration. Usually you will basically add this plugin to one of your previous configurations, so you can kind of stack plugins. You can apply a PEP plugin, the rate limiting plugin, and let's say a monitoring plugin to the same route to have everything enforced on one route, which would be the usual way. But to have it more, let's say, for demonstration purposes, I only apply the rate limiting plugin to this limited path, and I configure it that it only allows 3 requests per minute. If nothing else is configured, it will do the rate limiting based on the IP address, but the plugin supports a lot of different options. For example, based on authorization headers, which would be a better idea, for example, in case of using a PEP plugin in addition to the rate limiting plugin. So now let's take a look. If we go request our limited endpoint, we don't need an authorization header here because I don't have anything configured for this. We can do 1 request, get an answer, a second one, a third one, and for the fourth one, we get an API rate limit exceeded. We now have to wait a minute and we can request again, but our broker is basically safe from getting too much requests within a short time. And then we have the last type of plugin that I mentioned. This is about monitoring. So we want to see if something weird happens with our APIs. So if we get a lot of unauthorized requests, we probably should check who is trying to access our system without being allowed to. We can use another standard plugin here. It's called Prometheus. It doesn't need a lot of configuration. You can apply additional labels if you want, but normally the standard configuration is already enough. So I applied it also to the KeyRock path here, and you will get a nice little dashboard on Grafana if you apply it. I don't have a live demo for this because it basically shows nothing with a low amount of data that I put on here with this couple of demo requests. But yeah, you can see the request rate, you can see latencies, you can see the status codes. For automation purposes, we automated so that we use the Prometheus scrape method, which means we instruct Prometheus to retrieve the information from Kong. So we have to tell Kong that it should, or we have to annotate Kong with scrape enabled and with the port that the scrape endpoint is available, which is for the default on this plugin 9102. Okay, so that's mostly my part already. We have some links that you can further read. First is the one that I already mentioned, the IFOTrust tutorials, where you can find examples on how to put together all the applications and all the components and how you can configure them so that you have a working system in IFOTrust. Then there actually is also a UI available for Kong. I'm not a big fan of UIs for API gateways, but I know a lot of people do use it. So yeah, Konga is an open source front end, which is, as far as I know, pretty good and also actively developed. So take a look if you want an API, get front end for it. Then I linked the references for plugin development for Kong. So how to develop Lua plugin and how to develop a Go plugin. There's also documentation on Python plugins, but I did not use it yet, and it seems to be not used a lot. So I cannot say how good the quality of those tutorials is. So I would go with Lua Go for now. And then there's also my typical presentations repository where you can find the whole presentation from today. Yeah, that's basically it for today. Any questions? Maybe I should take a look at the chat. Some more detail about the character of interaction between Kong and iShare. I can. There will be more information about the whole iShare flow in the next couple of days. But the interaction between Kong and iShare is, so I did abstract iShare basically as one bubble, which more or less refers to the iShare flow. Because in fact, Kong interacts with two different entities in iShare. One is the authorization registry, and one is the this iShare satellite. The iShare satellite acts as the trust anchor. So Kong will retrieve the trusted list from the iShare satellite, and the iShare trusted list is basically a list of trusted certificates. So it gets back a list of what certificates, certificate authorities it should accept when it gets a JWT token. I've shown you the header in this JWT with the whole certificate chain. And iShare gives us a list of basically the list of certificates that we can trust in these headers. That's the first step of interaction between Kong and iShare. And after this is verified, Kong will also retrieve the policies from the authorization registry, the policies to actually be applied. This is normally not the same entity as we have with the iShare satellite, so which is why I would say this arrow is quite simplified. But the authorization registry can either be an external endpoint, an external service providing this, like for example the the iShare testnet instance that I used in my examples. It could also be Keyrock, because Keyrock has an implementation of the authorization registry endpoints. And yeah, Kong will then retrieve the policies from there and evaluate the contents of these policies and enforce it on the request. I hope that explains it a little. As said, there will be more information about this in the next days, also with some flowcharts and some additional diagrams. I did not prepare them for today, so I cannot show you something, let's say, more visible on the flow. Will we have Docker examples to deploy Kong? I can refer to the already existing official Docker examples for Kong. We don't have some specifically for FIWARE yet. Maybe Jason. So I know Jason played around with them, but I don't think there is a public example of using Kong in FIWARE with Docker. I'm not a very big fan of using it with plain Docker, because you run into some you can run into some very complex networking issues. But it's possible. I myself don't use it and don't want to use it. Maybe we will have some in the future.
At the moment, there is a very simple example in the pet proxy tutorial repository. It is basically showing off Kong as a PEP. Obviously, an API gateway is a PEP plus. It does other things like your logging, your rate limiting, etc., etc., etc. But the problem with the FIWARE tutorials is that they are designed to show off the simplest possible architecture. They are not designed to necessarily be scalable or secure or whatever, which is obviously a problem when you're trying to create a secure, scalable system. So what Stefan is saying of saying base your system nicely on Kubernetes, use your Helm charts and stuff like that, is actually a more robust way to go going forward. If you're just playing with it, sure, use the tutorial. And you can muck around with it, fiddle with it, and see what's happening. But once you're starting to architect a system properly, that's what I would say do it Stefan's way.
Or at least look for the official recommendations on how to run Kong with plain Docker. So there is documentation, and they have much more experience in running Kong in a plain Docker environment. Then can Kong be used to count licenses? That depends on how the license is provided. So it can be used, for example, to count API keys. I'm not sure if a direct license enforcement plugin is there. If it's counted, it can also be stored somewhere. You have to check the available plugins, and if not, you definitely can easily write one that does that. So this is quite easy functionality. Simply check, for example, an API key and put it into a database. So it can be used. I'm not sure if there is an out-of-the-box plugin that you can use for it, but in general, yes. Can you provide some more information about using verifiable credentials? I can, but I will not, because that's what Ruiz will now do. And the general question is the recommendation to use Kong instead of Wilma as PEP. My recommendation, definitely. I'm not sure how Jason sees it, but I would say use Kong instead of Wilma, yes.
My nuance is a bit different in that there, as we've stated, there are multiple options you can use within for security around FIWARE. So you could just as easily say I should use Telefonica Steelskin as my PEP. I want to use Wilma as my PEP. I want to use Kong as my PEP. It will depend on your architecture. Now, for the sort of architecture where you want to be using an API gateway rather than a simple PEP, obviously an API gateway such as Kong, and there are other API gateways out there, is the way to go. If all you need is a simple, no, you're not coming in here, mate, go away, then maybe a PEP is sufficient for you.
Yeah. Anything else? Any other questions? Else we can hand over to Jesus.
So, Nikos, you're going to get an hour-long answer to your question.
Yes.
Over to you, Jesus.
Hello. Can you first confirm that you can hear me well?
Yes, we can hear you well.
Okay, because I had some problems. Okay, so then let me share the screen. So okay, this is the first time, share the screen, the whole thing, share. So I'm going to talk about verifiable credentials, but I'm not going to explain in this session how this is integrated into the full schema of I4Trust or in general with data spaces. There is a special session for doing this next week on Wednesday, okay, if I'm not wrong. But I'm going to explain here, let's say, the basis of verifiable credentials, what verifiable credentials are, because there are people who already know, but there is a lot of people who don't really know, or at least the understanding that they have is, let's say, is not the adequate to understand how verifiable credentials can be used for the real world, for a real identification system. But what I'm going to explain here is the underlying theory of verifiable credentials with a demo, because the only way, a very simple demo, I'm not going to enter into the details of the demo.
Wait a minute. We're waiting for your presentation to arrive. Oh, there we go. It's back again.
Oh, really?
Yeah, that's fine. I can see it now. Dermot, can you, or Illyri, can you point out? Can you see the screen now? Can you just? Yeah. Okay, you can continue.
Okay. And by the way, the resolution of the screen is good. Do you understand the text? Because I am using low resolution just because of the internet. Can you read this screen right now?
Yep, that's good.
Yep. Okay, fantastic. Okay, so again, what I'm going to explain here is the verifiable credentials, how they work. with some details, of course, and then how it can be used, for example, for replacing the user ID and password, or even the login with Facebook, login with Google that we are all used to. Because the system that I'm going to explain is essentially an identification and access management system that can be integrated with almost any system in the world, including, for example, if you are a bank, you can implement this. If you are a public administration, you can. I will even explain something for real that is a project that is going to start by a public administration in Spain, a regional government, to use verifiable credentials, for example, for replacing the PDFs or the paper certificates for green deal certificates. Okay.
Jesus,
Yes.
your screen's not presenting again, so
I don't know what is happening.
It might make sense if you could send either Stefan or myself the link. We could do the presentation for you.
That's a problem. That's a problem because it was going to be dynamic. Let me change the resolution. Yes.
Okay, we'll just wait.
To high definition.
I'm agreeing with Dermot here. We're having latency issues.
Latency, because I checked and the speed was very good. Okay. Can you see my screen right now?
We can see the infinite mirror and the backup again. Yeah. Okay.
And right now?
Okay. Let's see how we can go. You can see the EBSI page.
Okay. Yeah, that's correct. Okay, because what I was going to explain is that this verifiable credentials thing, for the ones that you know, that already know, is not something which is special. It's not something which is locked to FIWARE or even to data space. It's something which is generic. It's so generic that the European Union, the European Commission, plus the so-called EBP, the European Blockchain Partnership, which is essentially most of the countries in Europe, in the European Union, sorry, they have created a project called EBSI, the European Blockchain Service Infrastructure, which has a blockchain infrastructure for doing cross-border services or for facilitating the delivery of cross-border service. But on top of this, they or we, because by the way, I am the DLT leader in FIWARE, but I am also participating in the technical working group of the EBSI project. Okay. So we are putting in place a pan-European blockchain services infrastructure based on blockchain to deliver several cross-border services. And one of them is identification based on verifiable credentials. Identification for verifiable or verifiable credentials for identification, but also verifiable credentials for other, let's say, as a replacement for digital documents. Any digital document or any document that you have issued by a public administration or issued by any private entity can be replaced by a verifiable credential and then get all the benefits. So I'm going to explain something based on EBSI, okay? Because this is generic, but then we will see the details. Let's because we have enough time, okay? So if you're interested on getting the full verifiable credentials story, you have here in this page, okay, if you look at this, EBSI, this is very good page with a lot of documentation and even YouTube videos to explain everything, not just the background theory, but how we are implementing in Europe this, and this is a technology which is not implemented let's say, widely in production everywhere, but this is coming. What we are doing in FIWARE, in the FIWARE Foundation, together with some other collaborations or collaborators, is implementing this technology now, or at least as a proper subset of the technology now. So you can start using this now in the experiments, but we will talk about this. It's an optional thing. It can coexist with the traditional user ID and password identification systems with the OAuth, I mean the traditional OpenID. As you will see, we are using, let's say, new versions of the OpenID Connect standard that supports more decentralization and verifiable credentials in the flows of OpenID Connect.
Jesus.
I don't know what is happening. This is, but this is not my PC. This is
it's the internet
incompatibility with the platform. No, because the internet is 100 megabytes should be enough. So this is the platform. What can I do? I don't know. Just say it again. This is Hermit. Okay, now, do you see my screen again? No?
Yes.
Yeah. So this is Hermit. Okay, whatever. Well, Hermit and my PC. Maybe it's because this is incompatible with Edge. I should be using Chrome or something like that. Okay, whatever. You just tell me when I have some problems. Okay, now let me explain. Let me go directly. Okay, verifiable credentials, because this is a fantastic document. Then I will enter into another presentation. So this is coming again from the European Commission. So again, this is very generic. You have a lot of documentation coming from EFSI related to verifiable credentials. They explain how they work. In action means what use cases are being implemented already in the EFSI project for cross-border identification and usage of verifiable credentials for example, diplomas, university diplomas. Then how decentralized identifiers work in the real world. Okay. Decentralized identifiers are a new type of, let's say, numbering system. So you can provide an identification to every natural person or business, but of course, integrated with the current eIDAS system, because everything that is being done, and this is exactly the same in what FIWARE is doing for data spaces, is fully compatible with the law, with the regulations, and is aligned with the upcoming eIDAS 2, okay, which is a modification to the current eIDAS framework. So there is a new regulation coming. It's not coming in 6 months. It's coming probably in the framework of 2 years or whatever. But it doesn't mean that we have to wait in order to get the benefits of verifiable credentials. And this is exactly what we are doing in FIWARE Foundation, is implementing the technology of verifiable credentials to implement identity and access management framework, which can be used today. Okay, but again, this is new technology. Then how the new digital identity system is going to work with verifiable credentials and compatible with the new eIDAS 2 regulation. How is the trust model for issuers? Because verifiable credentials are like the documents that you have in your physical wallet. Okay, so you have a physical wallet, which is maybe leather or plastic or whatever. You can have any wallet that you want. The wallet is not your identity. The wallet is a holder. It's a place where you store the plastic cards. You have different plastic cards. You have the plastic card probably issued by your country, the national ID. You have the driver's license. It's another plastic card that you have in your physical wallet. Then you have, or you may have, but this is not typical, your diploma, but you may have other plastic cards that have something in common. They have the same size, so they can fit in the wallet. And this is where the standard comes into play. There may be many wallets, but the wallets have to implement some standards. And the standards specify how the verifiable credentials, the cards, the physical cards, or the digital equivalent to the physical cards are shaped, what are the data models that they use. And then once you have these standards implemented by the providers of wallets, and then also by the issuers of these digital equivalents to plastic cards, because with plastic cards you have issuers that issue the card, then you have the cards in your wallet, and then you can present the physical card to some verifier. Okay, so you get from your wallet, from your pocket, then you get the card, and then you present the card. So exactly the same is going to happen with the digital version of these plastic cards. And this seems very natural, but up to now, we didn't have this. We had totally different systems for identification, very, very centralized. Well, there is a range of variation in centralization. Of course, federated OpenID is more decentralized than a single centralized provider. Like, for example, login with Google. This button promote centralization. This is very bad for the future of the economy, okay, or for the European Union. So what we are implementing is a system which smells and behaves exactly like the physical counterparts, like physical cars, but in the digital world, okay? So then you need digital wallets, of course. Digital wallets for natural persons, probably in the mobile, but also for entities, for businesses. And then you have enterprise wallets, which are server-based. We are implemented in FIWARE both versions. So you can have a wallet in the mobile for natural persons, or even for the legal representatives of companies. And then you have enterprise wallets because you can have issuers like certification agencies, GDPR compliance, whatever. They can issue credentials attesting something about a company. The company can have these credentials in their enterprise wallet and then present the credentials whenever some verifier is asking for those credentials, okay? Now, I'm not going to go through the details. You will see the demo, okay? Why verifiable credentials, okay? Because verification of documents and information is a challenge with so many problems, okay? Because we have 30 million businesses in the European Union, 140,000 local governments in the European Union, and 500 million citizens, okay? Then documents are very easy to fake and very difficult to verify, okay? But we have to live for the moment with this because until today, we have not been able to fix this problem, okay? So then we needed to create national registers. So we needed centralization in order to provide trust. Verifiable credentials with some other things provide the same level of trust or even higher than the same level of trust with much more decentralization, okay? And this is what this is explained here. You have these documents available in EFSI, so I shouldn't be going here, but this is a model. So you have an issuer of credentials, the holder, which can be a natural person or a business. You will find here typically natural persons, okay, because this is the canonical representation, and then the verifier. The credential is issued by the issuer because the issuer knows the holder. It's impossible that an issuer just sends a credential to the holder. Why? Because the issuer has to...
Jesus, can you try sharing again?
Yeah. Well, actually, it just stopped sharing.
Yeah, I was trying to do that for you because you kept cutting out.
Yeah, okay. Okay, right now?
Yep.
Yeah, I don't know why it stops. So again, in order for the issuer to issue a credential to the holder, the issuer has to know the holder, okay? Because the credential is basically like the physical counterpart is saying something about the holder. So the issuer can be, for example, a bank, and the bank can provide a document saying that the holder has an account with the bank, okay? So this is the owns an account, or that the holder is a good customer. Let's say is with a good balance, or public administration can attest many things. Essentially, every document that the public administrations provide to the holder can be replaced by verifiable credentials, and that's very easy. Okay, and then when the holder has these credentials in the wallet, like with the physical, then the holder can present the credential to the verifier. Who can be the verifier? Well, the verifier can be, if it depends on the credential, okay? But the verifier can be, for example, somebody renting a flat, or can be a bank because they want the verifiable credential generated by some public administration, or it can be the same as the issuer. Because one type of credential, and this is exactly what I'm going to explain here, could be, for example, an employer providing a credential like the employee badge to the holder, so the holder can present the credential to the different applications of the issuer, of the employer. So essentially then the employer, the company, the bank, the public administration itself can replace the existing identification system with one using verifiable credentials. So in the general ecosystem, the issuer is completely different than the verifier, and then the holder just receives credential from the issuer, and then they send the credential to the verifier. So the verifier has to trust on the issuer, and then this trust is implemented or achieved thanks to something called the trust framework. I'm going to explain a little bit about this, okay? But the details of the actual trust framework in data spaces, in I4Trust in this case, is going to be explained next week, okay? The actual implementation. Just to mention that in the context of cross-border services in the European Union, in EFSI, the trust framework is implemented using a blockchain. It's a pan-European blockchain which is operated by all the countries in a collaboration. So there is not a single operator. That's critical, because imagine that there is a single company operating the blockchain. Okay, that's like an Oracle database. Okay, the nice thing here is that nobody really owns the blockchain. Well, yeah, you could say the European Union, but not the European Commission. It's the whole set of countries. Each one operate one node, and then the nodes collaborate to make operational the blockchain network. This is a model which is different than the traditional cloud-based things. This is every node in the network, in the blockchain network, is operated maybe in the cloud, maybe on premises, maybe whatever, okay? But at the end, there is nobody, there is not a single entity which owns the ledger. And this is critical for the trust of the whole thing, okay? Now, having said that, as I said, the verifier has to trust on the issuer of the verifiable credential, trust framework, but also has to trust on who is presenting the verifiable credential. And this is done because the issuer knows the holder. So if one bank provides a document to the holder, whether the document is a physical piece of paper or a PDF digitally signed or a verifiable credential, then, because they are going to coexist for the future, then when the holder presents the piece of paper, the digitally signed PDF or the verifiable credential, the verifier has to trust using digital signatures. Well, on paper, probably not. On the PDF and verifiable credentials, the verifier has to trust on the digital signature. So why verifiable credentials instead of PDFs? Well, because PDFs, normally they have natural language. That means that the verifier, in order to check whether a PDF complies with the requirements of the business requirements for the application, they have to hire people to check that the natural language inside the PDF is expressing exactly what they need. Okay, so it's a little difficult. It can be done, and some organizations have tried to do this with PDFs, but in general, this is very complex. Instead, the verifiable credential is like a digitally signed PDF in terms of digital signatures, so it's using digital signatures, but the data inside is not natural language. It's a JSON document, so it's a structure. It means that you have a common representation, and then you have to make an agreement across all the ecosystem. Okay, the verifier has to understand the schema from the issuer. Okay, this again will be explained in more details in the session on Wednesday, and what is the actual schema that we will use in I4Trust and in general in data spaces. Okay, but the critical thing is that verifiable credentials per se, they don't solve the problem of agreeing on the data model. So depending on the credential, if the credential is a diploma, all the universities in Europe have to agree on what is the schema for the data model inside the verifiable credentials. Otherwise, it's an aimer because nobody understands the credentials issued by other. And this is exactly what is happening, by the way, because diploma, right now there are more than 100 universities who have agreed on this verifiable credentials schema. So in every industry, something has to happen. We need to agree on the data model for the verifiable credentials. It may be easy if the standardization of data models in the industry is already advanced. It may be difficult if it doesn't exist. But again, there is no magic, okay? But verifiable credentials is a fantastic method that once you have the data models implemented, then you can implement a very trustful or trusted and decentralized ecosystem using the existing data models, okay? And this is exactly what has been done, for example, in diplomas. Data models already existed. Nobody was using them, by the way, because it was a data model that this was not being used in the papers for the diplomas and so on, but right now it's going to be used, okay? Now, so here you have 3 key technologies, okay? One is verifiable credential, which is a new way of expressing information. You have the claims, okay? You have the metadata, which is data about those claims. So what is the type of credential? For example, you have to understand that this is a credential issued by a university. This is a medical doctor diploma or whatever, okay? And then you have the proofs, the signatures. You have standardized ways of making the signatures. This is like digital signatures in the European Union, for example, for invoicing, okay? Then you have the blockchain ledger. The implementation that we are doing in FIWARE gives the ability to use as a verifiable data registry. I'm going to talk a little bit about this, using not a blockchain, okay? So the usage of blockchain is optional. We are doing something which decouples verifiable credentials from the blockchain. This is coming from FC. FC is using blockchain. Okay, fantastic. But you are not forced to use a blockchain. What you have to have is a compatible implementation at the level of APIs, and that's it. Then you are hiding the whole thing. Of course, if you don't use blockchain, then your ecosystem is not as decentralized as probably it should be, okay? But this is another problem. And then you have wallets. And the wallets have to implement, again, standards, because the wallets have to talk with the decentralized ecosystem, and also with the, they have to help to have the verifiable credentials in a standard way, and they have to be able to receive credentials from issuers and send the credentials in a standard way to the verifiers, okay? Now, why invest in these technologies? You can see the whole set of reasons. Well, essentially, it's almost impossible to fake, but very easy to verify. So this is completely new, okay? What are verifiable credentials? You have here a lot of explanation, but let me just try to visualize this a little bit. So if you can see my screen, yeah? Can you confirm, Jason?
Yes.
Okay.
At the moment, yes. I'll tell you when you go blank again.
For the moment, okay. So this is a demo for showing the components. This is not a demo of how this is integrated with the i4Trust ecosystem, okay? But this is exactly what is available for using with i4Trust, and we will explain more details on next week, okay? Now, this is a demo because instead of having, remember, you have in the ecosystem an issuer, a verifier, a wallet, and then some underlying trust framework, which is a decentralized verifiable data registry. I will explain a little bit more later. You don't see here because here I want you to visualize how this works, okay? Now, in this demo, you have both components, issuer and verifier here. But again, this could be an example of a company or a public administration providing verifiable credentials to someone that then can be used to be verified by the same entity, okay? For example, there is one very important health entity in Spain who wants to avoid integrating the different identity providers that they have on their different backend applications for different purposes, because they have inherited this, okay? Because typically businesses are very complex. So instead of doing this, they have stopped this, and they are going to implement something based on verifiable credentials, because then the verifiers can be not only one, can be many, all the different backend systems they have. They can issue a credential to the wallet, and then the wallet can use the verifiable credentials to enter into the verification without the requirement to have a single integrated identity provider in the whole company, okay? And that's simplifying enormously this type of problems, okay? Now, with Issuer, and this is a demo because you have the components in the same thing, okay? So let me see. This is a demo interface, of course. Okay, so I have here already a credential. I'm not going. Okay, I can just create a new credential. Okay, with this button. But again, you have this is a credential. So this is JSON. This is a context. This is a credential data model. Then using the JWS suite. Then the credential schema that we are using is, in this case, is the blah, blah, blah. The ID is here. In this case, it's just a demo, okay? On Wednesday, you will see the integrated thing with FIWARE components and so on. But this is essentially the packet delivery service schema, okay? You already know about packet delivery. I mean, the i4Trust demo application. So this is credentials that packet delivery will accept, essentially, okay? So then here you have the credential subject, which is who is in this case, the natural person receiving the credential. Again, can be a business, no problem. In this case, Olga is the name of my wife, and this is me, okay, whatever. Then, and the ID. Inside the credential, you have roles. Why? Because the credential has to have enough information for the verifier to make all the authentication and authorization decisions. So here you have the roles that will be verified on the verifier, okay? And then you have different things like the issuance date, when it was issued, who was the issuer, okay? Remember, DID stands for Decentralized Identity, which is something like a numeric key, for example, in this case, okay? Identifying uniquely the issuer. And then you have the proofs. These are JSON proofs, okay? And then, again, the type of verifiable credential, well, or the type of, let's say, schema is, first is a verifiable credential, subtype, packet delivery service. You can have, again, as many types of verifiable credentials as you wish. In EFSI, for example, they will deliver verifiable credentials for diplomas and verifiable credentials for identification, okay, called verifiable IDs, and so on, okay? In this case, we have chosen this schema. Now, how do you go and authenticate to verifier? Well, you will have a login. Login with a verifiable credential. Again, this is exactly the same as the login with Facebook or login with Google, but in a very decentralized way, because you are going to log in with a verifiable credential that the holder has actually physically in their wallet, like presenting the national ID or presenting the card that you have in your physical wallet, okay? But first, here you see that the wallet says there's no certificate. Okay, we have to get the certificate. From whom? I told you about the issuer. What is the mechanism? Okay, in this case, the mechanism is very standard. So this represents the QR code. By the way, what you see here is my mobile. It's actually my mobile connected to the PC. Now, if I click here, I can click with the finger, or I can click with this. Then, if this works, yeah, okay, you see that this is my mobile. And then I'm going to scan in my screen, and whoops, okay? So if you are still seeing my screen, which may be difficult, then you can say that it says, you receive a verifiable credential. You can save this it in this device for easy access later, okay? Please click save and save the certificate. I'm going to click with the finger in my actual mobile, and then this is the credential. So if you remember, okay, this is the mobile, so this is just for the demo. This is not what you have to show to the user. This is just for you, okay? So you see, oops, sorry, exactly the same credential that I was displaying before, because remember, I was using this credential, okay? So it's exactly this that has been sent via the QR code. Nothing fancy, very easy to do, okay? The important thing is that this is not displayed here, is that this is, of course, displayed using an authentication session. We don't want everybody to have our credentials. So the first thing that the issuer, remember that the issuer knows very well to the holder, for example, a bank. So you have to log in into your bank, and then you ask for the credential, and then the credential is displayed after you authenticate. So nobody except you can get access to this credential. That's very important, okay? Now, if we go back, then we see a different screen. So you see that we have one single verifiable credential. This demo has the ability to have only one credential. Of course, you will have access to a wallet for the experiments, which is fully featured, okay? But for this demo, this is very easy to show. Then you have the details again, okay? So you can see, oops, sorry. Where is that? Actually, it blocked because, okay, now, details. Or maybe, what is happening? Let me refresh the screen. Okay. It's not being displayed here. I see this in my mobile. I don't see here. Okay, let me see if this works. Okay, in any case, you have the verifiable credential, and then you can use this for authentication. So in order to authenticate, we need to go to the verifier. Okay, now we are going to log in. So in order to log in with a verifiable credential, there are two ways. One is with a mobile, but remember that we may have enterprise wallets and so on, and then you can log in with what is called the same device flow, okay? But for natural person, for example, and for representatives of companies having a wallet, okay, they will scan this. By the way, if I don't do this, this session will expire, okay? So let me see if I can, yeah, okay, so you see, right? So now I'm going to scan the QR code, not for getting the credential, it's for sending the credential, okay? So if I scan this, you see, okay, the issuer or verifier send an authorization request. Essentially, this is an OpenID Connect authorization request, but it's SIOP, self-issued OpenID provider compliant. So this is a new type of authentication request, which is being defined by the OpenID Foundation, okay? So we are implementing this standard like EPSI. Then the verifier has requested a verifiable credential to perform authentication. Okay, let's send this credential. When we send the credential, automatically, the verifier has received the credential, okay? You have here the information from the credential, and then we are going to simulate that using this credential, we access a protected service. Why? Because here we have all the information needed from the user. Very important. In the same way that when you present a credential, physical credential from your physical wallet to a verifier, the issuer has no idea of where, when, or to whom you present the credential. Okay, if you present the Spanish ID or the national ID.
Screen again, Jesus.
Again, okay, let me. Well, I was explaining something.
And it's back.
It's back. So yes, yeah, it's back.
It's back now.
Okay, but did you see the previous things? I mean,
yes.
how authenticated. So one very important property of this system is that implements the same, let's say, privacy mechanism as with the physical credential. With the physical thing, once your national body has issued a credential to you, or a university has issued a diploma to you, a physical one, okay, or anybody has issued a credential, physical credential to you, and you have this in your wallet, physical wallet, when you take your wallet and present the physical plastic. Okay.
Right, can you try sharing again?
Yeah.
It was fine for most of your demo.
Okay. No, but that's enough. That's enough. Okay, to show what you will have available. Okay. Now, what I was saying, okay, is that using verifiable credentials implements the same security mechanisms or the same privacy mechanisms that are implemented with physical documents. Because again, with a physical document that you have in your wallet, the issuer of the physical document has no idea of to whom you present the physical document. If you are going to enter into a discotheque, for example, okay, and you present your national ID because you are
Not again.
more... Okay, forget about that. I will do this later. Okay. Now, then, in
Good
the
now.
same... Sorry?
It's good.
Again?
Yeah, you're visible now.
Okay. I don't know why. I don't know what is happening. Okay.
I'll just keep warning you if it goes off, okay?
Yeah.
And it's
please.
off.
Thank you. Off? I don't know. I don't know.
And it's back.
Okay, let me put lower resolution. But again, this is... I have full network. Let me see. HD, no, low definition, and then share the screen. I mean, right now, I don't know. Okay.
Yeah, again. Good.
Okay, good. So again, let me try to finish the argument because this is important. So this is very, very, very decentralized, okay, more than the typical OpenID Connect Classic, because even federations, because in order to authenticate, this authentication system that you saw is very private between the holder and the verifier.
And
nobody else. Okay, just when because I don't need the screen right now. Okay, Jason, I don't need the screen right now. Okay, when I need the screen, you start again. Okay, let me try to finish the argument. Okay, so again, where I was. Yes, so when you present a physical credential, this is only between the holder, between you and the verifier. Nobody else has access to this, let's say, transaction, unless the verifier is required by the regulation to disclose this type of things. But this is then the verifier disclosing this information later. When you are presenting this, it's just you and the verifier. And this is something which cannot be done with any other identification mechanism. With this new identification mechanism, when you present the digital credential, it's just you and the verifier. And that means also that it is incredibly scalable. It's massively scalable because it's like a parallel system. You never have to have a centralized system or a centralized entity intermediating into the authentications, okay? Like you have to have with typical OpenID implementations, okay? And this is very powerful. And this, by the way, we all hope that is going to be the future of identification in the European Union, because this is, again, implementing a trusted ecosystem, but in a very decentralized way, very difficult to attack, because once you have the credential in your wallet, okay, of course, they can attack the issuer and they can attack verifiers, but there is nothing to attack, okay? Because you have 500 million citizens and 30 million businesses just interacting peer-to-peer, once against the other. So verifiable credentials is essential for implementing a real peer-to-peer system. You may say, no, blockchain is the one. Well, both, okay? Both, because you need some verifiable data registry. Okay, now I'm going to stop sharing again. I don't know what is happening. Let me see. Okay, can you see my screen again?
We're getting infinity mirror at the moment.
Okay, fantastic.
Yep.
Okay, so this is the demo. But if you see, after the identification, I am going to simulate how to access a protected service. And essentially, this is a simulation, but in this screen, you see two things, okay? Again, this is something that, forget about this, because this is accessing Google, which is not authenticated. In the session next week, you will see this integrated to the i4Trust ecosystem. What is important here is that this protected service received a JSON web token. This is a JOT JWT, a JWT, that has been derived from the verifiable credential, because the verifiable credential is something which is typically long-term. The verifiable credential is like the documents that you have in your physical wallet. So they expire, but they do not expire in 1 hour. They typically expire in 1 or more years, okay? Because they are attesting something that typically doesn't change. Of course, you can implement a verifiable credential ecosystem where the credentials themselves expire very soon, okay? It depends on the business requirements. But the typical authentication mechanism, then, what it does is that what you saw, the flow, you present the credential to prove something, but then once the verifier is satisfied with this proof, the verifier creates an access token, which then is exactly the same or has the same properties as the typical access tokens created by the classical OpenID Connect. And then is this access token the one that has to be used for accessing protected resources? And the same would apply in a machine-to-machine scenario, okay? So it doesn't matter that the machine has a credential. The credential is long-term, and then you have to present the credential to get an access token from somebody, and then this access token is the one that is much more efficient than using verifiable credentials, okay? Because using verifiable credentials has some overhead. But once you exchange a long-term mechanism like verifiable credentials by a short-term one, a much more efficient like a JWT token, then this access token is the one that can be used. Let me just display the contents of this JSON Web Token. And you see, oh, we have the verifiable credential, okay? But again, in a different format. But the most important thing is that you have inside the JSON token, the JSON Web Token, you have the rows. This token, okay, if we go to the verifiable credentials from the wallet, they have been digitally signed by the issuer. This token has been derived from the verifiable credentials, but essentially it has been digitally signed by the verifier. Once the verifier has checked that the credential corresponds to the, let's say, to the reality. So anybody that trusts on the verifier, on the digital signature verifier, can just use the access token. When is this used? Well, as I said, for example, if you have a company that can receive verifiable credentials using the logon with a verifiable credential, and then this component inside the company generates an access token, then anybody or any other component inside this company can just trust on the verifier component, and they don't have to trust on the issuer. So the trust on the issuer is just on the act of presenting the verifiable credential. Again, the verifiable credential is checked and then it's exchanged by an access token. Let me go to the questions for the moment. Okay, this is explainer. What is that? What is that? Okay, there are too many. Okay, but I think it's good that we address the questions right now. This is the website. Where do they blank? Come on.
At the bottom, the last question, I'll read some of the questions out for you. The last question at the bottom, what about losing your phone or losing your wallet? What happens at that point?
Well, the situation is much better than when you use your physical wallet, okay? When you lose your physical wallet, remember that somebody has issued something to you. So if you have a diploma, you can ask your university to send a new diploma, okay? Because the facts that are being attested, I mean, the fact that we are using a blockchain in EPSI or in other scenarios and using verifiable credentials does not mean that we are implementing the same model as Bitcoin or Ethereum, No, we are implementing a model for the 500 million citizens, and many of them are not going to be able to, let's say, have on custody the private keys, if this is the question about the private keys. No, well, you can choose to do this, but most people, like myself, will use the less, let's say, paranoid mechanism, trusting on somebody to have my keys. Why? Because at the end, the important thing is that if I have a diploma, I know that I can ask for the diploma as many times as I want, okay? If I have a national ID, it's the same thing. When you lose your national ID, you go to the police, at least in Spain, and then you get a new one. The passport, again. The driver's license, again, the same. So it's exactly the same model as with physical documents, with one exception. Because of the digital nature of those documents, me personally, I will choose to have the documents, the digital documents, in my wallet, but also in a provider that I trust. And there may be different trust providers, okay? But again, there are many different models that can be implemented. So if you lose your phone, then you get a new one, and then you recover your verifiable credentials, because the verifiable credentials are not like tokens that if you lose a Bitcoin, then or the private key, then you lose everything. The verifiable credentials are not tokens, are and this is why they are called verifiable credentials. They are attestations made by somebody else. This is something that you never lose. You just accumulate. If you have a diploma, you don't lose the diploma, or you don't lose the fact that you are graduated in medicine, for example. Once you have done this, this is something in the real world. So the verifiable credentials attest something, again, that an issuer knows about you, and then is just attesting, okay? So if you lose your phone, okay, I would be more sorry about losing my phone than about losing my verifiable credentials. It's a bigger problem losing the phone than the verifiable credentials, okay? So the situation is much better because it can be done even in real time. So I recover this, I recover my identity, and once I have recovered my identity, because my identity is myself, I'm not going to lose this, and I am still have the typical, the traditional, the plastic identity system, okay? So once I can identify with my bank, with user ID and password, I can request for, I have lost the certificate or the verifiable credential that said that I am a banking customer from you. Okay, I can request another one.
Okay, no, there's a supplementary question which makes sense. Is that instead of Alberto losing his phone, I've stolen his phone.
Yeah.
What's to stop me from impersonating him and using his credentials off his phone?
Well, because you have to apply exactly the same mechanisms in those phones as are being used for preventing that once you lose your phone, then somebody can enter into your bank and make a transfer to their account. Okay, so it's exactly the same situation. And by the way, this doesn't happen, okay, at least in civilized countries like in Spain. Okay, so even if you lose the phone, of course, you can put you can have a paper in your phone, in the back of your phone, putting all the pins or all the pins or the passwords. If you do that, then come on, you lose your credential, which is a diploma, then you lose your all the bank information, even without verifiable credentials. So the problem with verifiable credentials, again, is less problematic than with the traditional mechanism of authentication. So again, if you lose the phone, you may have a problem. But I would say that the biggest problem is not with the verifiable credentials, it's with the other typical traditional identification mechanism, okay? Why? Because with the verifiable credentials, the system that is going to be developed is you can have 1,000 credentials for authenticating in 1,000 websites with only one password. And by the way, the password is not going to be checked with a centralized entity. So right now, for example, I have in my browser, I have more than 100, let's say, user ID and passwords stored in the you know how to set the passwords. Because in theory, you have to have a different user ID and password for every website, which is never, ever true, okay? But then you have to have very strong passwords. With verifiable credentials, with one single, and by the way, this can be protected with biometric identification system. Biometry means biometry which stands in web auth, okay? So not biometric databases in the provider, not like in India, but like in Europe, okay? Because most probably in Europe, centralized databases with biometric data for these type of things are going to be completely prohibited now and in the future, and I will vote in favor of this. But when you use biometry in your phone, you know that your biometric data is not being sent to anybody, okay? It's kept in the physical device and in a very secure way. So this is the way to secure access to verifiable credentials. And again, then you will be able, with just one single method of identification, to use verifiable credentials to authenticate in 1,000 websites without having to remember or to have stored 1,000 different passwords. Okay? I don't know if I answered the question.
I think Alberto is happy. If he's not, he can put some more in the chat.
It's Alberto Palomo. Okay. Hello, Alberto. Okay, I can explain. Okay. hello. Yeah. This is very critical. So the important thing, and by the way, now that it's Alberto, I can say that in the EIDAS2 regulation, just recognizing the problem that we typically have with Bitcoin and Ethereum and so on, which is typically your if it is not your keys, then it's not your money. Okay, which is true. In order to avoid that, then users, in order to not to have the private keys written in paper or with some special devices, this is a nightmare for most citizens, not for techies, not for high valued or for people who are very, very smart on these type of things. We need to think about the normal people. Well, many people will never use digital mechanisms, okay? But this is just being solved. So we have to think about inclusive mechanisms for, let's say, the majority of people. So the majority of people will use, for example, money like in the current banking system, because with the current financial system, you can have the money either in a banking account, not investments, okay? I'm talking about the typical savings. I mean, the typical worker that has a problem to reach the end of the month. By the way, we have a lot of those in Europe, and we have to think about them. So if the people are not digitalized, we need paper. So I don't think paper is going to disappear. So we need inclusive mechanisms for identification, okay, and proof of things. But once you are digital, we need a digital system which is also inclusive. So we cannot expect that if you lose your private key, then you lose everything. No. It has to be the same as if you forget your user ID and password for entering your banking account. You don't lose your money. You just have an inconvenience. If you keep losing your user ID and password, then you have problems. It's an inconvenience, but you never, ever lose anything. That's very important. And this is exactly the same thing that is being recognized in the regulation. So in EIDAS2, it is recognized, and this is my opinion, that trust service providers, if you know what it is, I mean, Alberto knows, but the rest of the people, I mean, TSPs, there are, I think, 200 and something in Europe, are the ones that provide, for example, the digital certificates, time stamping and seals and so on, okay? So they are very regulated entities, which provides the, let's say, the roots of the digital identification system in Europe, okay, for many things. And the new EIDAS2 regulation recognizes that there may be a new type of service offered by, let's say, new types of trust service providers. Of course, I am already working with several current TSPs, which are going to play an important role in the new future. And the new future is verifiable credentials for many things, not just authentication, also digital signatures, where the private keys are going to be stored, managed in the cloud by special entities. Those special entities have to be highly regulated, okay, as they are right now, but they will provide additional services to the ones that they provide today. By the way, there may be some entities. Sorry. Yes, of course. There's a question here saying, does the FIWARE framework support cloud-based wallets? Yes. For example, the enterprise wallet has to be cloud-based. Okay. Again, cloud-based can be both for a company. I think an enterprise can have an enterprise wallet, no problem. But then we also support both natural person wallet, mobile, and then enterprise. For the demo, okay. Let me. Do you see my screen? No, because I stopped sharing. Okay. If you see my screen, let me see. If you see the.
We currently see your screen.
Okay, so if I go to the verifier and then say login with a verified credential, again, the QR code is for a wallet in a mobile, so you can scan. But here is where I'm going to log in with, let's say, an enterprise wallet. So this is an enterprise wallet. Okay, so you don't need to scan. And then again, if we have here, this tab is waiting for authentication. This tab is, it has to be configured, okay? The enterprise wallet. Here, when I do send, this is going to change, okay? Click send. You see, the same, okay? So, going back to the questions, so it's cloud-based, and then is the wallet FC compliant? Well, we are doing this, okay? We are using components which are already FC compliant. This is a critical thing. Our wallet, the wallet that FIWARE is providing, let's say today, the next week, and then experiments can use, is not just in the list of certified wallets. We expect to do this in January. And then, very important, okay? The fact that this is going to be FC compliant, everything that we are doing is FC compliant, means that you are not forced, or you will not be forced, okay, let's talk about several months, okay, not in the first day, you are not going to be forced to use the FIWARE wallet. You could use any other FC compliant wallet. So if Nikos, if you made the question because you already have a wallet which is FC compliant, okay, you will be able to use your wallet to authenticate in the i4Trust ecosystem. And I would be more than glad to talk to you. I don't know if... Okay, okay, that's it. So that's the idea. So it's standards. If you know FIWARE at this moment, okay, you have open source components and then standards. So we are a standards-based entity. We are promoting standards. And in this case, we don't want to invent a new way of doing things if somebody's already defined the standard. And for us, the European, let's say, standards and the best practices entity is EFSI, okay? So we are doing everything. Our motto is this. If EFSI has already defined something that fulfills something that we want, our requirement, we don't reinvent the wheel. We just adopt this. Just one very important question. That does not mean that we need to run on the EFSI blockchain network. It only means that we are compatible with the best practices, with the APIs, with everything else. But we are implementing a parallel system. We don't rely on the EFSI blockchain network. We rely, for example, in the case of the wallet, on the standard way of delivering credentials, defining credentials, and then exchanging credentials with the verifiers, okay? And how to, and the trust framework that we provide, and you will see in more detail in the next week, is essentially based on the EFSI framework. Of course, with some additions, because EFSI is not a data space. Data space may have different requirements, so we have defined something which is an extension. But whenever we have found something which, okay, we see, we need this, and we see this in EFSI, we don't reinvent the wheel, okay? Now, more questions, Jason.
There one question from 35 minutes ago from Roman, which is, what kind of virtual machine and core technology inside the EBSI platform?
Okay, then this is a question related to FC, not about the FIWARE implementation. Okay, having said that, essentially we are using the same thing. The FC platform, the FC blockchain network, is based on actually two technologies. One is Ethereum compatible, okay, but it's based on Besu, if you know. So it's compatible with the Ethereum virtual machine. Actually, Besu is implemented by Consensus. Consensus is one of the providers of the clients in the Ethereum blockchain network. So if you have essentially, if you know how to develop for Ethereum smart contracts, you know how to develop for EPSI, and you know how to develop for let's say the framework, the blockchain that FIWARE is integrated with, okay? Because already FIWARE has components integrated with a blockchain network which is compatible with its specification, okay? The other technology is Fabric, but I would say everything related to verifiable credentials, diplomas, and so on, most of the things are using the Besu technology, which is Ethereum compatible. So the virtual machine is the virtual machine from Ethereum. Okay, exactly the same. And it's compatible. And by the way, I mean, there may be some things related to gas, okay, and the ether in the network, but I would say that in general, most of the smart contracts that work in Ethereum work much better in EPSI or in the, in this case, the Alastria blockchain network, which is the one that FIWARE is using. And by the way, I am a board member of the Alastria Foundation in Spain, where we have a network with 200 nodes and so on. And by the way, just as a signal that this is a little bit the future, let's say the Spanish government just announced 11 projects in a very ambitious digitalization program for the regions of Spain. And one of the 11 initiatives is the creation of a Spanish blockchain network for not just for the public administration, but essentially dedicated to small and medium enterprises, big business. So it's a collaboration between the public administration and the private sector. And the blockchain, this blockchain network for the future, is, let's say, fully compatible and is going to be fully interoperable with the, let's say, pan-European EPSI network. EPSI is focused on cross-border use cases, but whenever you need more, let's say, national or even regional use cases, you need a different blockchain network, and this is the blockchain network that Spain will create, okay, with together with the regional communities. This is the RegTech program. And this is a very ambitious project, and I think this is going to put Spain in the leadership of these type of things. And again, everything that we are doing here in FIWARE is going to be, let's say, compatible with whatever is coming from this blockchain network, whatever is coming right now from the Italian blockchain network, which is called IPSI, for Italian Blockchain Service Infrastructure, because they have already started to create this blockchain network. Again, compatible with EPSI, because EPSI is going to be the anchor blockchain network operated by all the governments of the European Union. And then you will have other blockchains which are dedicated to other use cases with more capillarity in some cases, but of course always interoperating, because at the end, when you are going to do cross-chain, for example, from Italy to Spain, then we may use EPSI for this trust framework, okay? Okay, so let me then go a little bit fast on this, because I explained about this. This is what you are going to see on Wednesday. If you're interested in this, again, this technology is going to be available, the proper subset, because this is not yet finished. Well, actually, there is never anything which is finished. So, but what we are going to provide the experiments with is something that you could use even in addition to the traditional OpenID Connect. Okay, so you will be able to use both, because the same way that you may have different identification methods. Okay, but this is going to be available for experiments if you wish. So if you want all the details of how this is tied with or integrated with I4Trust, and how this is going to be also available for other, well, for data spaces in general, then Wednesday is going to be your session, okay? But again, one thing is EPSI, but the other thing is that everything that I have explained to you is developed in the context of something which is here, is the technical components within the Data Space Business Alliance, okay? Technical conversions. This is an important thing.
Jesus, are you trying to share something because we can't see anything?
Well, I tried, but okay, it disconnected again. Yeah, the presentation. I don't know. Share the screen, maybe, but it doesn't give me any notice. It just goes. Okay, now you see this?
Yes.
Okay, so then how many minutes do I have yet?
As long as you need. I overran by half an hour yesterday, so everyone's getting value for money.
Okay, whatever. So then let me explain also how everything that you heard about, okay, or you saw, and what you are going to see on next week fits into the, let's say, the wider ecosystem of data spaces in Europe. Okay, then these associations, the FIWARE Foundation, but also the Big Data Value Association, GaiaX, and many of you probably know about GaiaX, and the International Data Spaces Association, they joined together in the DSBA to create something like a roadmap which is aligning the different technologies. Because every association is interested on data spaces, but they were, let's say, doing their own things, okay? And now we join together and then we define something for discussion, okay? But it has been already accepted, for example, in GaiaX, in IDS also, and BDBB, okay? So what is this? Well, it's in parallel with the existing identification systems to define a self-sovereign identity, which is not complying with the full, let's say, crypto-anarchic principles of the origins of self-sovereign identity. This is self-sovereign identity for the real world, okay? So it's to implement something as decentralized as possible, but which is fully integrated into the real economy, the real society, not just to allow people to bypass the government for not paying taxes, for example. No, it's how we can make the system, the current economy, the current social system more efficient, even more inclusive in many cases, okay? And then how to make this keeping trust and decentralization at the maximum level, okay? And how to reduce the role of trusted entities to the minimal essential. Again, this is based on standards, this is new, but again, as all innovations, I would say that there is not anything radically new. It's the combination of things that already exist to implement something that could not be done before, okay? And then with privacy by design, okay? I already explained about that. Because the interaction among participants is peer-to-peer with no intervention by the central entities. You still need central entities for issuing the documents. Come on. How can you prove that you have a diploma if the university cannot attest that you have a diploma? So you need the university to send you the diploma, digitally signed by the university. But once you have this, nobody has to go back to the university to check anything. You are self-served. This is the concept of self-sovereign identity. You have all these components of your identity. Your identity is not just identification. In many systems, they mix all together, okay? No, you have identification. You can still use your digital certificates, traditional digital certificates to authenticate if you want. But in order to prove that you have a diploma, you don't have to use either paper or PDFs, because again, PDFs are not as efficient as verifiable credentials. You can use verifiable credentials to prove things that you are. And this is your identity. Your identity is the identification, a number that you are assigned at the beginning of your life, but then what you are, what you have, what is your past, and the capabilities that you have, and maybe also some other credentials which are more, let's say, lucid, okay? Like, for example, based on the trust that your friends or the community has on you. You can also have credentials which are not hard, okay? So verifiable credentials are very, very flexible. And by the way, the model is flexible because the verifiable credentials can be very private in your wallet, but again, stored also in a verifiable data registry or in a centralized database that you trust, okay? So it's like digital documents. You can manage them as you want. And then it is efficient, very, very scalable, because once you have the document, you don't have to go to a central entity to do anything else, okay? And it's very resilient because it reduces the single point of failures to the minimum in the ecosystem. The ecosystem is essentially, except the onboarding and the issuance of the credentials, which if you think about a diploma, you get a diploma once, and then you prove that you have a diploma many times. But proving that you have the diploma, again, is peer-to-peer. So it's impossible to let's say, destroy the system, almost impossible, okay? And of course, it can coexist with other mechanisms. Now, again, we are using traditional EI-digital certificates provided by the European Union Trust Service providers as in order to boot the whole thing. And the fact that you use verifiable credentials doesn't change that in order to prove your initial identity, you need digital certificates, for example, in I4 Trust. So it's exactly the same as with the classical, let's say, OpenID in I4 Trust. Exactly the same, okay? You need something to prove your identity. But with this schema, you have the digital certificates for the holder, again, natural persons or businesses, because the businesses, in order to engage into a contract, you need somebody, a person. I mean, it's impossible that a company does, the machines can do anything automatic. In order to sign a contract, in order to get a compromise or to enter into an agreement, you need that some representative of the company, typically with a digital certificate, saying this person is not just a natural person, is the owner of the company, or is an authorized representative of the company, then there are digital certificates for this. So those are the digital certificates typically that this person will hold in the wallet, saying, I am an authorized person from this company, so I can sign on behalf of the company, okay? Again, the company, forget about the decentralized autonomous organizations for the moment. So in the current legal system, a business cannot have a machine doing things automatically. There has to be always a person. Of course, once you have done this, you can make many, many things automatic. You don't require manual things for many things, okay? But again, everything starts from the current trust framework based on digital certificates and based on the current EIDAS regulation. But what we are doing here is using this to bootstrap the verifiable credentials ecosystem, okay? And then you have the issuer, the holder, the verifier, and then the verifiable data registry. And then the verifiable data registry, because I already explained many things about this, can be implemented, as I mentioned, with any technology. You can have an Oracle database, a MySQL, PostgreSQL implementing a verifiable data registry, or even a cluster of databases, or some replication system with many different databases. You don't need a blockchain, but the most efficient way that I know, okay, because after many, many years with the blockchain, with the real one, okay, not with cryptocurrencies, because I've been for 15 years, 35 years in banking, 15 in Banco Santander, I can assure you that I have never, ever seen any technology providing this type of services. This is not a database, okay? This is not a database. This is just an append-only log. But I have not seen such a network being able to run in such a way, in such a robust and resilient way, with so minimum requirements and so cheaply, okay? I can tell you that in a bank, in order to achieve the same, it would be millions and millions of euros, okay? Now, having said that, we are implementing this based on a blockchain, but the rest of the ecosystem just uses the verifiable data registry using APIs. So you can implement the whole thing without a blockchain. For example, if the issuer and the verifier is the same company, and this is issuing just credentials to customers and to employees, so they can use them with their systems of the same company, why do you need a blockchain? You just put your database with all the public keys here and the public information, and that's it, okay? You don't need a blockchain for most of the problems in this world. And that's also the problem with the blockchain, that the guys on the blockchain space try to put blockchain everywhere, which is wrong, okay? Because many problems don't require a blockchain. But then identification authorization, okay? Because I was speaking about the trust framework. So the trust framework is implemented by this. Again. So the trust framework is implemented by the verifiable data registry, okay? But then on top of this, we're making use of identification authorization, implementing a decentralized identity framework with verifiable credentials. And then in order to avoid centralized identity providers, we are using OpenID Connect, but not the traditional OpenID Connect. We are using SIOP version 2, self-issued OpenID provider, okay, that enables all participants to send identity data. And then also, in order to transport the verifiable credentials and the verifiable presentations in the flows of OpenID Connect, we are using, like EPSI and like many others, OpenID Connect for verifiable presentations, which is this symbol, okay? So we are using OpenID Connect, but again, the new standards, not the old ones, okay? And align completely with EPSI, so everything you do, if you use these components, let's say you have some guarantees, 100% is almost impossible, always, but you have guarantees that this is fully aligned with EPSI and is compatible with EPSI, and so you will be able to deploy this everywhere where you have EPSI compliant things. Now, this is critically important, okay? You have two different things for natural persons and juridical persons. Wallets for natural persons and wallets for juridical persons. Oops. Interaction flows based on SIOP and then OpenID Connect for verifiable presentations. And then these are the flows. I can enter into the details of the flows, but again, I'm going to explain this. This is just the presentation. I'm not putting here the issuance, because the issuance is very easy, because the issuer knows the holder. Again, the university knows you, so they can provide the verifiable credential in many different ways. But the difficult problem is how the holder, whether this is a natural person or a business, can prove something to a verifier, which may be the first time that they see each other. So they don't have the trust, they don't have the time, because in this world, something is true. I mean, and technology is never, ever going to change this. Trust depends on time. The more time you have been doing things with another party, the more you trust on another party. Technology can help, but it's not a replacement for time. Now, having said that, technology can make more efficient the exchange of trust and then the increase of trust in the ecosystem. And this is exactly what we are doing. So in this case, two parties that don't know each other, you have the holder, which has to prove something to the relying party. And the typical way of doing this is that they exchange something, but then at the end, the relying party is going to the IDP, to the identity provider, because the identity provider is the trusted party for the verifier. In this case, no. This is the identity provider, let's say. But the trick is that the trust of the verifier is going to be built based on the credentials that the holder presents to the relying party. And the credentials have not been generated by the holder, have been generated by a university, a government, a bank, another company. So instead of having one single identity provider for making this identification flow as with the OpenID Connect, okay? Because in this case, if you have a button login with Facebook, then the verifier goes to Facebook for every interaction. So Facebook knows where you do the logon, how many times, at what time in the day. So they know too much. Okay. So what we are replacing, or we are replacing this identity provider thing, very centralized, even in a federation. Okay, this is too centralized for my taste. Okay, at least now we are replacing this with trust on the issuer of the credentials. So the verifier has to trust on the university. Well, we need a mechanism to check for the verifier that this university is really a university and is able to issue those type of credentials. If I present a credential, which is a verifiable ID, which is a special type of credential which will be issued by the governments, then the reliant party will have to trust on the government. Okay, but this is not a problem, right? Okay. Now, if I am going to prove that I have money in an account or that I have a banking account, the reliant party will have to trust on the issuer of the credential, which is a bank. So they will have to trust on the bank. Again, centralized entities do not disappear, but they do what they are supposed to do. A bank has to give you a digital document attesting that you are his customer. A government has to send you a document attesting that you are a citizen of this government. A university has to do the same thing. So all the issuers just give you documents, and those documents are the ones that you send here. And the flow is very easy. So you have to initiate the transaction, let's say, okay? You saw in the demo that I just click a button in the verifier, okay? So if I go to the demo, okay? Sorry, the session, okay? So I am there. When I click here, this starts the flow, okay, in the button. So this is number 0, which may be different depending on the use case. So this is the reason I term this 0. And if this is a company, then this 0 may be different, okay? But once the reliant party knows about this, then number 1 is the reliant party saying to the wallet, okay? Again, whether this is a cloud-based wallet or a mobile wallet, it doesn't matter, okay? If it is a mobile wallet, it uses a QR code. Number 1. If it is an enterprise wallet, it uses the traditional redirection or whatever, okay, like a traditional OpenAI Connect. But the important thing is that the reliant party is asking the SIOP, please, in order to provide access to my services, you need to prove these facts, which translated to verifiable credential is you have to present to me a verifiable credential of this type with this information inside the verifiable credential. And by the way, digitally signed by somebody that I trust, okay? But this is a different story. So if you want to get a discount for students of a given university, you will have to present the diploma of that university. And this verifier will ask in number 1, you have to present a diploma of this and this and this university, because I'm going to provide a discount to the universities that are in my area. I'm not going to provide a discount to somebody coming from Spain to Germany, but I'm going to provide a discount to the German universities that I have agreements with them. Okay, that's it. So I don't have to check with the university because I ask for the credential, then the wallet is going to display to the user, hey, the verifier has requested this type of information. Do you agree with this? This is also important, okay? Because it also avoids the typical phishing that happens in traditional identity systems right now. I mean, in order to avoid phishing, the user should be, when interacting with the browser, they should be checking the small lock, okay, that says this is a different, they have to check even the URL or whatever. With this system of verifiable credentials, because this is built, and you will see the details on next week, we can present a lot of information about the verifier, which is registered in the verifiable data registry, which is not here, okay, displayed. But the verifiable data registry is a decentralized registry with a lot of information about the identity of businesses, not natural persons, businesses. Only public information is in the public repository. So it's forbidden to store anything related to personal information about natural persons in any public repository. And this is true for any public repository, like, for example, Facebook or whatever, okay, or Twitter, or publishing information about my customers in a newspaper. This is forbidden by law, okay, by the GDPR. So the same thing happens with the blockchain or any other database which is publicly accessible, okay? So only the business identities are stored in the verifiable. So thanks to this verifiable data registry and the trust framework, we can display to the user who is requesting this, And by the way, they have to put the reason for asking for this information. And once this is done and completed, it's going to happen something also very different to what happens right now. I mean, if you provide access to some information to a verifier right now, today, you have to click in some buttons, okay, saying, yeah, I agree with this, I agree with this, and so on. But the user doesn't keep a register of this. Well, this is completely different here, because there is going to be a register of the acceptance that I sent something, some data, for some purpose, and this in GDPR is very important, okay, the purpose. The wallet is going to keep a registry of when, how, what data, and for what purpose has been sent from the wallet, okay? That's very important. Okay, so then, if you, these are using the OpenID Connect flows, but the important thing is that in number 3, because in number 2 is the user has accepted to send the credential, the wallet retrieves the credential if there is an appropriate credential, because it may be that the user doesn't have the credential, okay? Then the user can just, in real time, they can ask for the credential to the issuer. Imagine that this is asking for the diploma of the university, and then the user says, oh, I don't have this diploma. Okay, no problem. They can ask the university in real time, because the university can issue a diploma in real time. No problem, okay? In this case, well, not a diploma, it's a verifiable credential representing the diploma, okay? So they can request the credentials in real time if they have, if they know that this is going to fulfill the requirements from the verifier, okay? Now, the verifier is going to receive the credential inside as a JSON thing inside the flows of the OpenID Connect. There is, with the new standard, there is a new, let's say, in addition to the ID token, there is a new field, okay, in the OpenID Connect flows that is named VP token, okay? And then inside the VP token, VP stands for verifiable presentation. So the act of sending a verifiable credential, a diploma, from the wallet to the verifier is called verifiable presentation. And inside the verifiable presentation, you can send one or more verifiable credentials, okay? Normally, you may need one, but for different requirements, the verifier can ask for your verifiable identity, for your diploma, and for the proof that you actually living in this city right now from the local government, for example, okay? And then you can provide those in a single verifiable presentation, or as happens today, you can provide them in different interactions. Now, once the verifier has this verifiable credential, they can check the verifiable credential, including the verifier signature, and then number 5, this is exchanged by an access token, which is exactly the same access token that would be generated in traditional OpenID Connect flows, okay? So up to 5 is different for verifiable credentials. Starting from 5 is exactly the same. So then you can guess how you can use it. This is just some details about what we are providing, because we are going to provide components that, I mean, together with the sample applications, you are going to be able to build issuers, and also not issuers from scratch, but typically you have an existing issuer, and what you have to implement is those 2 components. So it's 2 layers. So you will have core issuer components that give you the ability to integrate verifiable credentials with the existing business backends. Essentially, just to simplify the whole thing, the role of issuer is to get business data and then generate the JSON structure for a verifiable credential, digitalizing this, and then sending this, making this available for the holder to get the credential. Okay, so you'll have this. Then components for onboarding, okay, implementing the OpenID Connect flows, again. And you see here ESIF, okay, because we are using the same APIs. Then components for the wallet. So, okay, you are going to get a standard wallet, so you have to care about the wallet. But what happens, and this is going to happen, if you want to integrate a wallet, like, for example, this bank that wants to use verifiable credentials. Okay, many companies already have mobile applications or PWs, okay, web applications. Okay, no problem. you will be able to also integrate the wallet functionality inside an existing native application, or make an application with many more functionalities if you want, but then using verifiable credentials, or just use the standard FIWARE wallet for doing authentication and identification. No problem with this, okay? By the way, we don't have components for native application, okay? This is everything for the moment is a web application. But which can be integrated to a native application with the typical mechanism that you use for this, okay? Whatever. For the holder, okay, for supporting decentralized identifiers, then for credentials, these APIs, okay? So this is going to be explained in more detail. Then components for verifier. Again, these components just are for credentials, not with integration to I4Trust. This is later, but a minimum set of verification policies to say, okay, I want to accept a diploma. I want to accept a packet delivery service certificate credential. I want to accept this, but not issued later than whatever, or complying with these conditions. So you need to check the verifiable credentials, just the verifiable credentials, to comply with your business policies, even checking your business data in real world applications, okay, whatever, this is available. And then access control. This is already using, for example, as you saw before, Kong. So there is a plugin of Kong developed by Stefan, by the way, that uses or implements this flow, okay, the flow that you saw. So it can use KeyRock or KeyCloak as a PDP. So the client sends the verifiable credential, and then this plugin sends whatever is needed. So you have authentication, authentication and minimal authorization, okay? Because if you are not using the authorization registry of FIWARE, then you have limited, let's say, policy implementation here, but you can still make useful business applications. For example, this company that wants to issue badges for employees, KeyRock or KeyCloak have more than enough functionality to implement this, and then just implementing this to make the request to the context broker. By the way, as you guess, because we are using standards, this is context broker in the context of I4Trust, but you can use all those components for making authenticated access control to any resource that you want, okay? We also provide, not today, okay, but we'll make this available to the experiments, okay, a verifiable data registry which is implemented on top of an actual blockchain network. So whenever you want to go to production, because you may have chosen these components, you will have a production blockchain if you want to go into production whenever you have production requirements, okay? This verifiable data registry, again, is right now based on the Alastria blockchain network. We are going to expand the availability of blockchains. As soon as they are compatible with FC, then we are going to make this transparent to you, because if you develop applications in the way that we explained, then automatically you are going to be supported on, or you are going to support, your applications are going to support the different verifiable data registries, whether blockchain or not, that implement the same APIs as you can see here. Essentially, the FC APIs. Again, this does not mean that your applications or that we are using the FC blockchain network. We are using the FC best practices and APIs, okay? But in a different infrastructure. And that's it. So, I mean, I can keep talking about this for eons, but I would say that for the moment it's enough. And, well, I will answer more questions, but don't, I mean, if you are interested, the session is on Wednesday. Okay, Roman. Okay. Do you have planned to implement the support of the centralized identity standard? Yes, but we have already done this. I mean, in the demo that you saw, we have used, if you didn't see, the DID key. Okay, let me share the screen. We are already using DIDs. Now the question would be, okay, what DID methods are we going to support? Now, in the demo, if you look at the details, okay, let me see here. No, the mobile is not there. Here. You see this? This is the DID key. DID key is fantastic for natural persons and for privacy. Now, other DIDs supported, essentially, DID FC, okay, the one from FC, and whatever is coming from Gaia X, which is probably going to be DID Gaia or whatever, and DID Web, you can integrate this. I mean, because we are agnostic to the DID. As soon as you have a DID method implemented in the ecosystem, you can implement this DID method. Okay. What API do you use for the implementation of blockchain? Okay. Now, you have the blockchain, and then you have, on top of this, you have a layer which is implementing the same APIs as in FC. Okay, I don't know why I stopped sharing. If you want to know, we are going to provide all the documentation, okay, of course, but just to give you, oops, where was that? FC, okay? So for developers, APIs. Do you see my screen, Jason?
Yes.
Okay. So in APIs, you have different, well, this is also, okay? You have APIs for authorization, the DID registry, accessing the ledger, which is lower level, okay? You have notifications, you have storage, for example, because there is a layer of storage on top of the plain blockchain network. So you can store something in a transparent way for the applications. You have timestamp API. Timestamping is the basis of almost everything trusted, I would say, in an ecosystem. So this is equivalent to the standard TSP timestamping services using a blockchain. It's not, let's say, legally valid in some environments, but it's legally valid in some others. Okay, so for most applications in this world, this can be used. Then you have different registries. One important is the Trusted Issuer Registry. Trusted Issuer Registry is the set of APIs that can, okay, or get an issuer. So we are going to document, we have documented this just for the I4Trust and for our implementation. I am showing the FC ones because the thing that I said, you can access the blockchain network however you want. But the rule that we are, let's say, imposing is that you access this via an API, which is a layer of abstraction, and this API is based on FC. Okay. What about support between FC and Hyperledger Fabric? Well, FC supports Fabric, but the problem of Fabric is that because of the consensus algorithm, in FC, we are not using Fabric for all the, let's say, the wide range applications, including verifiable credentials, because Fabric requires that all the, let's say, the consensus nodes, the orders, as they call it, which is equivalent to the verifiers in Ethereum technology, or the miners, the consensus algorithm is CFT, is crash fault tolerant only. So it's not BFT or Byzantine fault tolerant. So it doesn't give you the protection against malicious actors, and it doesn't give you the decentralization that we need in FC and in Alaska and in the future Spanish blockchain network and in many others. So Fabric is typically for consortiums. Okay, consortiums where you have banks with banks, because whenever I was in Santander, we created consortiums using Fabric, and Fabric is fantastic. but then the level of trust that you have in the operator of the network is very high. So, yeah, it's compatible with Fabric, but in Alaska, for example, there was a Fabric network available that the operator operated by Telefonica and some other, but at the end it was closed because for that type of network, which is, let's say, the public permission model, which is permissioned, okay, but then it's public in the sense that it's public access, Fabric still cannot be used, okay? Okay, let me see. Consensus on Fabric is pluggable. Yes, but there is no official BFT consensus algorithm. I know about the things that are being done, for example, from Besani, from the University of Portugal, and some others. I actually wanted to develop a consensus algorithm, which is BFT, okay? But the problem is that there is not an officially, let's say, endorsed and highly trusted BFT algorithm, unless you tell me the contrary, and this would be fantastic news. The official, let's say, is not out of the box, and then you can plug your consensus algorithm, and then you have all the problems of supporting this consensus algorithm. So this is the reason why, for the moment, in FC, we are not using any BFT, okay? You need Telefonica Trust ID. Yeah, what is the... consensus in Fabric is pluggable, but you need to modify nodes and consensus algorithm. Yeah, but okay, let me. I don't. You try to implement the ID in Fabric. Telefonica? Well, yeah, I think so, but I don't know a lot about details. But yes, that was the idea. Okay. Yeah, that was the idea. But now the problem is exactly what I explained to you. That at the end, if you want to implement a highly decentralized system using verifiable credentials, the verifiable data race, the blockchain has to be really decentralized, or at least with a minimum level of decentralization, because I know that the maximum decentralization is Ethereum. Well, not really, because 4 Chinese operators are not more decentralized than 28 countries. So for me, it's much more decentralized, the FC network, and by the way, the future Spanish network, because it's going to be operated also by the regional communities. And in Spain, we have almost 19 countries, okay? So it's much more decentralized, the FC network, or the current Alaska network, than Ethereum, for example. Another thing is whatever you think, okay? That's opinions. So with Fabric, it's impossible. You need one operator. Yeah, the sequence, yes. So Telefonica was the single operator of the whole Fabric blockchain network. But that was something that the participants in the Alaska ecosystem didn't want, because they wanted something more decentralized. For example, the current Alaska network, you have currently seven, okay? It's being increased, okay? You have different companies operating the nodes. So the Alaska blockchain network doesn't belong, not even to the Alaska association. The association doesn't operate anything, any infrastructure. The association just promotes the creation of the blockchain network, and the blockchain network is being operated by the companies that they want to operate. By the way, the rules is that if you want to operate a validator, you can, if you comply with the technical policies. So there is no exclusivity, there is nothing related to this. This is impossible to achieve with Fabric currently, okay? Or at least we don't know how to do that. No, that's true. Hyperledger Fabric can decentralize, but the level of decentralization is, let's say, much lower than what you can do with Quorum or Besu. Why? Not because the CA. The CA is important. The important thing is the orders. Who operates the orders? Because the orders are the ones that order the transactions, so they can make censor the transactions. So the one that controls the orders can stop the network because they want. And by the way, more importantly, if an attacker, for example, Roman, you are from Kiev? You are from okay, whatever. Because I was to say something, okay? But in any case, if one of the orders, because of the consensus algorithm, okay? If you use let's say the official consensus algorithm, which is CFT, if somebody From Ukraine. Okay. So, привет. Okay, so whatever companies can be part of ordering services, I know. No, they can do this, but then the problem is that if you have, you can have one company operating everything, but it will be exactly the same as if you have a cluster of MySQL, for example. Imagine this: you have a cluster, and then the different nodes of the cluster of MySQL is operated by a different company. You can do that. The problem is that with the current consensus algorithm, again, is CFT, and this is in the Fabric documentation, so I'm not inventing this. If you compromise one order node, you have compromised the whole blockchain network, because the consensus algorithm is not Byzantine. So Byzantine means that even if you have one or maximum 1/3 of nodes compromised, the network is still trusted. So you have to compromise different nodes from different providers. And by the way, implemented with different technology, okay, which is very good. For example, in Ethereum, you have Go Ethereum in Go, you have parity in Rust, then you have, well, the Python, I don't think it is going to be used, okay, whatever. But at least you have different technologies, and diversity is very important. So in Fabric, the typical scenario is that one company operates all the others, because at the end, if you have different companies, you are not making the system more robust. You are making the system more fragile, because instead of having one single company which can focus on protecting the orders from the malicious guys and actors like the Russian guys, okay, then you have created an environment where the boundaries are much wider and it's more difficult to protect, like an empire, okay? So then you have orders being operated by different companies, and if one attacker enters in one company, then the whole network can be stopped, okay? That's the idea. So we need a Byzantine tolerant consensus algorithm in Fabric, but this is not critical for Fabric, because until now, okay, because they have been implementing consortiums, and that's not a problem in a consortium. And by the way, CFT algorithms like Raft, okay, which is the consensus algorithm, the standard consensus algorithm in Fabric, is more efficient or more faster, consumes less resources than a BFT1 by nature. Okay, this is just because of mathematics. Okay, so BFT costs more, but the level of protection against malicious actors in terms of cyber protection is incredibly high, and this is the reason why I told you that being in a bank for so many years, okay, in the bank we didn't use BFT. Why? Because all the servers were protected by by ourselves, and then we could protect with firewall, with whatever, okay? And then we had also additional protection mechanisms. But if you had to run a distributed network where you have different entities operating different parts of the network, today I would use BFT, not necessarily blockchain, okay? I would use Byzantine fault-tolerant protocols, because they are already very, very mature, robust, and they are fast enough, and they don't consume a lot of resources, okay? But we can talk, if you want, we can make a session on this, because this is essential. Because again, if you implement verifiable credentials, but at the end you use Oracle or Raft is the algorithm being used by Kubernetes, by Cockroach DB, by all these distributed databases. Why? Because they are typically operated by a single company. Even distributed across the world, but operated by a single company, Amazon, Google, and so on. Okay? That's critically important. CFT is incredibly good for those environments. But if you have a system operated by different entities, okay, you can assume the risk. But the best solution is a Byzantine fault-tolerant algorithm. And there are many different types, okay, of Byzantine fault. For example, proof of work is BFT. It's a horrible BFT implementation for many use cases. For other use cases, is the only possible use case. Okay, so I'm not against Bitcoin or Ethereum. I'm against Bitcoin and Ethereum for logistics in food chains or for digital identity, for many use cases in the real economy. That's not, especially in the European Union, this is not the right way to approach the system. Okay, and for the Green Deal. Now, what else? DLT is your passion. Okay, then we have to talk in other Roman and the others. Okay, so we have here something which is my passion also. Well, I am fully dedicated to this blockchain. I joined the FIWARE Foundation 1 year ago to join the world of smart environments, smart cities, data spaces, and so on with the blockchain, because blockchain is not the only technology that I have to use. Blockchain is used just for a small percentage of the whole application, but it's a very important thing. Okay, and the real things are in the applications. Okay, Golang-based implementation BFT Smart. Okay, that will be fantastic. That will be fantastic. Yeah, BFT Smart is oops. BFT Smart is the one from Alison Besani from the University of Portugal? Or is the one coming from Zurich Research? I mean, Bucolic and company. Okay, sorry. Yeah. No, but okay, actually, just to tell you, did you know that the first version of Hyperledger Fabric, the one that I tested as soon as it was available, okay, implemented a Byzantine fault-tolerant consensus algorithm? And did you know that they took it out because the company supporting this, especially IBM, wanted to create consortiums where the blockchain was operated by IBM, for example, or by those companies. So they didn't really need a BFT consensus algorithm, and they implemented Raft. But if you look through history, the first implementation of Hyperledger Fabric had a BFT algorithm. Okay. And if you speak, because I have been collaborating with for example, Marco Bucolic and so on, okay, from IBM Research. Right now, Marco is not in IBM, he's in Tendermint, I think, okay? But they expressed their concerns because they thought that it had to be Byzantine fault tolerance because of the things that I expressed, okay? But they couldn't get the attention from the, let's say, the implementers, because you need muscle to implement this and support this, okay? So many people in Hyperledger Foundation really think that a BFT algorithm is needed. And I'm glad that there's going to be a Golang implementation of BFT Smart, because this is a good algorithm. That the problem, if this is the one coming from the University of Portugal, it was very, very good, but because it was implemented in Java, the integration with Fabric was like a nightmare. Having a native Golang implementation makes this very, very easy, okay, or easier. And then, if you have a Fabric implementation of this, I like Fabric. I have used Fabric in production, by the way. Okay. Okay, any other questions? Remember, don't forget about the session next week. Here, it was just the theory and why we are doing what we are doing, okay?
Well, thank you very, very much, Jesus. I think it's definitely the case that the presentation, the words were much more powerful than the slides today. But we could, as you stated, we could go on forever. There are continuing sessions. I think we've got another 3 sessions. One on Monday, Tuesday, Wednesday, and of course you can always reach out to us to get even more information. If you want to listen along for a second time, we will be putting this onto a public video channel, even if the video didn't work terribly well. and we hope to see you soon. In this session, should be able to replay schedule. Why other replays this schedule? It's all to do with the matter of how AirMeet works. I believe you may well be able to replay it once we close this session. But it's even if you can't replay it through AirMeet, it will be possible to view the video in a relatively short time. So thank you very much for attending today. I certainly learned a lot, which is always a good reason to hang around for an extra hour and a half. Let's meet up again tomorrow. And for those of you who want more of Jesus, he's back on Wednesday. See you soon, folks.
Tomorrow is Saturday.
You're back on Wednesday.
Yeah. Yeah, but no, but you said that we see
each other
Monday.
Tomorrow. Yeah, it's Friday today. Yeah, it's late. It's late. It's late for me anyway.
Okay.
Yeah, I think Andre just summed it up. Thanks very much for the conversation. It was a conversation. Even if you're typing on your side, you're actually getting a two-way interaction. So let's continue this on later on, which will be Monday. Okay, see you soon, folks.
Okay, bye.
And you too, Dermot. And you too, Alberto.
Oops. I wanted to end this.
I'm trying to end the session and it won't let me. Great. End session. Are you sure to end session? Yes. And it won't let me. Great.
Yeah, but where is that button?
I've got that button.
Okay, so I close the browser and that's it.
You close, you disappear. X. Pause session. End session.